Oh, good. That's what I wanted, was to kick everybody out. That's good. That's a feature, not a bug. Perfect. Hopefully everybody knows to come back in after that interesting option. It said end the meeting, but apparently, sorry, it said leave meeting, but apparently it ended the meeting. So I apologize. All right. Well, we'll give everybody a second since I took everybody on a little field trip. While we're doing that, is Mike back? So this is a discussion that comes up quite frequently. And so let me just spend a moment to showcase this. So Mike was asking, like, is there a playground where like we can just like pop something up and just play with AWS? Unfortunately, AWS is always billing, right? So while they don't charge you for a lot of things and a lot of stuff is exceptionally cheap, one thing to keep in mind is that they focus a lot on what they call the free tier. Now, here's the problem with the free tier. You cannot enforce the free tier. In other words, you can't go in and say, look, I only want to use free tier resources. If I violate and use something other than free tier resources, please stop me. You can't do that. And they won't let you create educational/student accounts that prevent you from billing, charging yourself. Now, that being said, there's two things that you probably want to know is that if you do decide to start an account, one, it's really hard to actually rack up hundreds of dollars unless you just leave resources running. If you leave resources running, you could easily rack up, dollars, maybe tens of dollars pretty quickly. But it actually is remarkably hard to get to hundreds of dollars, especially if you don't leave anything actually running. The second thing is that if you label your stuff as test, just as a general habit, like you tag everything with test, and if you start a VPC, it's called test VPC, where it has the word test somewhere in there. There have been friends and compatriots, and you'll see some of them out on Twitter, who have gotten hit with a $70,000 bill because they let something run for 8 months, ignored all of the billing warnings they were getting, and then the next thing you know, it's like I just rang up, whatever, 17,000, 70,000. It's like a bill. Amazon is remarkably forgiving when you contact them, especially if there's no evidence of production usage in the account, and especially if there's test in the names. They're like, oh, you're just an individual, you're not a startup, you're not associated with a particular organization. They will typically forgive tens of, if not hundreds of thousands of dollars worth of ring up. Now, I'm sure there's cases where they didn't actually forgive the debt, so I wouldn't consider that to be a foolproof solution. But in general, if you're going to mess around, one, don't leave any resources running. Two, try to stay within the constraints of the free tier, which means, like, for example, you get one, like let's say T3 micro, for example, for free for a month. You can run that 24/7 if you want to. Remember, that only lasts for a year. So when the account's created, the clock starts ticking. There's other things like you get 5 gigabytes of S3 for free for the first 12 months. You get an RDS database for, again, a T3 micro. So there's lots of stuff in here. Some of the stuff is free forever. Some of it is only 12 months free. So make sure you know the difference. But if between the API gateway calls and SNS and SQS and Elastic Block Storage, there's more than enough here for you to kick out, a small proof of concept and turn it off, and you probably won't see a dime be spent. So just something to be aware of is that the free tier is actually useful, but unfortunately you can't put any blockers or limitations to say, I don't want to go outside of the free tier. So that's just that little caveat there. Otherwise, you're going to use your own accounts. If your company is gracious enough to provide you with accounts, you still actually have to be accountable for the billing and whatnot inside those accounts. So, I don't know what your policy is, but in general, you probably want to run your own account. Even even for organizations that give training accounts to people, they usually come extremely locked down with all the security compliances and policies and whatnot put in place. That can be great for making sure that there's adherence to company policy, but it won't let you play with everything. So again, you probably need to open an AWS account using your own email address and just manage it from there. So Mike, I hope that answered that to the next level.
Yeah, it absolutely does. I do have the free tier account because I was testing with this before. I was just curious if during this, if there was like, unlimited tries or something to poke around, we can just destroy it when we're finished. But I'll continue with my personal account.
Yeah, there is no better answer at this point in time. If you haven't signed up, there's a gentleman named Corey Quinn who runs the Duckbill Group, and the Duckbill Group is like a billing analysis agency. He's also one of the snarkiest and funniest people in the industry about AWS. And so one of the things that he frequently has ranted about to AWS, because he's their unofficial like head of marketing, which is kind of funny. That's weird. So what happens is he has ranted about how if AWS, if you wanted to win the market, one of the best things you could do is just create free student accounts for everybody to use. Hold on. I don't think I'm distracted. I seem to be typing the right thing. He frequently argues that if you would just give us educational accounts that people can get familiar with and play with, you'd actually win the market long term because people would be familiar with your tool and be more comfortable and use it more. So just know that arguments are frequently made to have that happen. One thing that if you do run your own account, just to mention this as a side note, is that there is a budget section in here. This budget section will allow you to create budgets for all the services in AWS, including overarching and individual, like if you want to manage DNS or containers or whatnot. If you do run your own account, I highly recommend that the first thing you do is come in here and create a budget for what you're comfortable spending every month in your AWS account. So notice that I have an overall budget of $100. So what happens is it's going to notify me if I get within 80% of that. But I notice that I also have budgets for S3, for general networking, for EC2, for CloudWatch and other monitoring tools, for general DNS, for any data stores, and for containers. Anything outside of that, I don't usually use. So I don't, SageMaker and Ground Station and all that. So just know that if you do it, one of the first things you want to do is go here and create budgets for yourself. And as a general rule of thumb, most organizations have budgets for their enterprise accounts at the billing level as well. So they know when they've deviated, right? When the aberrations show up. Okay. Oh, good, Dave. I didn't know that. So Cloud Guru, yeah. Linux Academy used to do the same thing. They give you playground access to AWS accounts. It's good that you all have access to that. Okay. So let's talk then about Compute, unless anybody has any questions. I promise not to kick you out of the Zoom or do anything else weird this morning. So let's have any questions before we get started after an adventurous 15 minutes. No. Okay. Okay. So we're going to talk about Compute. We're going to end up doing a lab. One thing just to make sure that you saw me do it, just to make sure, is that I am going to activate lab 2, and I am actually going to pre-warm the lab. So that way, when we get to the lab, you won't have to sit there and wait for it to provision. So we should see it say it's provisioning here in just a second. There we go. Good. Okay. So here, Amazon, is asking these interesting questions about, things that we typically don't know enterprise-wide about our organization. So here's this though is probably one that at least, local answers are actually still incredibly relevant. The thing I'm curious about, and ignore the answers for the question for a second. How many of your workloads, like, would you estimate, like, for example, how many of you are using EC2 instances? I would assume that would be most of you. But the thing I'm actually more curious about is how many of you are using containers, either EKS or ECS or Lambda functions. How many are you using either containers or Lambda functions for your workloads?
My team runs a production workload that runs in ECS.
Good. And let's see. My thing is blocked. I think that was Rakesh.
Yeah.
Rakesh, so question for you. Why did you go with ECS instead of using EKS?
Oh, it was a decision made before I joined the company, and that was one of the first questions I asked. Why are we not using EKS? And I believe we are exploring creating an EKS cluster now, but we haven't done it yet. I think it makes more sense to run it in EKS, just because of how easier it is to set up, scaling, and well, I never used ECS before, and EKS is a more directly managed Kubernetes service. I think it just makes more sense.
Okay. So anybody else, by the way, using containers? Okay. We're going to come back to that, Rakesh. Anybody else using Lambdas? Like serverless? No? Okay. Interesting. Good. So Rakesh, just to say this, is that actually going with ECS as your first choice, especially if it's a new team, to containers, is actually, in most cases, it's a better choice, actually. Because ECS is actually easier to use, and the learning curve for Kubernetes is pretty steep, actually. Whereas ECS is a proprietary thing for AWS, and so it's actually pretty simple to use, and there's a lot of integration. But to your point, it's not an industry standard. So, scaling and integrating third-party tools and all that, none of that's going to happen with ECS. So typically teams will start with ECS and then move over to EKS, and as they ramp up and learn the Kubernetes ecosystem and kind of Argo and Flex and Weave and Helm and all the stuff that they're going to use for that. So that is a natural evolution, and it is actually the path that we recommend. So I know you're kind of like, well, we should have gone for Kubernetes first, and if someone like yourself or other people, the rest of your team was very familiar with Kubernetes, people could start with that. But it's actually recommended that you start with ECS before you get to EKS if you have no familiarity with Kubernetes, because having worked with Kubernetes now in production at scale, like I just did a proof of concept for the NFL, and there were like 49,000 and change containers/pods, right, in the ecosystem. And I mean, we had like over 1,000 nodes. So my point to that is that it is a beast. Kubernetes is a beast if you are not familiar with it. And so while AWS makes that easier, it's not something that people want to lead with. So it sounds like you are doing the perfect thing if they started with ECS and they're moving to EKS. So, but I understand your frustration. You're like, this is an industry standard. Now I got to learn all this proprietary stuff. But a lot of the concepts translate, so it should be easy to migrate.
Yeah, it's a fair point.
All right. So, okay. Well, that being said, just how many of you have actually run workloads on EC2 then? Right. So let's ignore serverless and containers. How many of you run workloads, production workloads on EC2 out in production for AWS? And obviously some of your roles I don't think like directly, right? But how many of you have like shepherded or fostered? Maybe you were part of the security audit, maybe you were part of the design team, right? Maybe you were part of the requirements gathering and team, or maybe you were part of operations. I have no idea. No? Okay. Good. That's actually good. If you had, it's probably maybe a rehash for you, but let's get into it then. Okay. So the call to action here is about, a compute needs, which in general, there's three broad strokes here. You're either running an operating system that's virtualized, you're running a container, which is just process virtualization. Don't let anybody fool you. There's no operating system in there. There's binaries, but no kernel. And then we've got serverless, right? So those are the three ways of hosting an application: is in an operating system, in a container, on an operating system, or in serverless, which is just really functions. It's not really a full app. So, there's a bunch of needs here that are being defined with a wide range of requirements, but you need flexibility. You need flexibility to resize those virtual machines and to add them and shrink them. You need, flexibility to add containers/pods and shrink them. And you need flexibility to add multiple instances of your functions for Lambda, like to expand them and shrink them, which all that gets done for you automatically. So it's easier at that level, right? And all that's important because if you're not using elasticity with your compute, you are overspending in AWS. And that sounds like a really like arrogant statement. I promise you, if you are not using elasticity in your compute layer, you are overspending in cloud and you're not really using cloud the way it's intended to be used, which is elastically. So the module objectives for compute here are to talk about the various compute services that are available, talk about what an AMI is, which by the way, when you see the words AMI, if I say the words golden image or like boot image, most of you are going to know what an AMI is. That all it stands for is Amazon Machine Image. And then how do you decide which EC2 instance types are best for your business? And I have a website, by the way, that's going to like simplify that very easily for you that I'll share with you. It's not in the documentation. And then how can you optimize your cloud compute instance cost based on your business needs? And then what is Lambda? How does it work? Now, notice that containers are not in here. There's a whole section on that later. So we'll talk about containers. They do assume that you know what containers are, but I'll make sure that we are level set on that, because if I ask most people what a container is, most people can't really explain it that well. So, and here's our architecture. So notice that we're going to add a few pieces in today. So part of it is that we've got, Lambda, which is serverless, which, Lambda in particular is great for those one-off functions, those things you used to run in cron jobs. Lambda is particularly good at that, but it is actually good for event-driven architecture. So you can actually define entire customer journeys and customer workflows with a series of Lambda functions that are being managed by what's called step functions, which is like an orchestrator for Lambda. And then notice that we've got servers over here, these app servers, and they're, in an auto-scaling group, which we'll talk about that later. But these app servers are of a certain size with a certain number of processors and a certain amount of memory. How do you figure that out? What are the different like design types of virtual machines that Amazon offers? What does that look like? So we'll talk about that. So here we go. And then we're going to have an honorable mention, by the way, just to say this for high performance computing, because Amazon does allow you to control how clusters of systems are either spread or contained on their ecosystem. So it's amazing. I'll be frank about this. I would have never thought some of the options that both AWS and the other providers have come up with, I would have never thought they would have done some of the things they've done, because it's just, frankly, it's awesomely ridiculous, some of the flexibility. So we'll talk about it. Okay. So they've tested virtual machines. Is there a solution to meet different requirements when it comes to infrastructure? So first of all, the answer is, particularly with AWS, the answer is yes. But I just want to draw some really clear lines here. This is not a product, so you're not going to use this by itself. I don't even know that this is here. This is for VPS hosting, so you're not going to use this. This is not for enterprise usage. I don't know why that's there. This is so you can put on-premise hardware, like Amazon's like hardware, in your data center. Most people are not going to use that unless you don't want to buy any more hardware and you just want to extend your cloud into that. But just say this, that use case I can see actually happening, but it's a little bit more rare. And then the other one is VMware's, kind of depends on how heavily invested you are in VMware licensing. And then Beanstalk, by the way, is just a wizard for EC2. I probably wouldn't use that unless you're just getting like, you're a developer and you need to start up a best practice infrastructure, and you don't have time to really like go through and learn all the best practices. Beanstalk is kind of where you start, kind of like you start with ECS over here, but you end up over here at EKS. Beanstalk is a place where you start. Most people don't stay on Beanstalk. I have a buddy at Equifax who, when Equifax, you may remember, they got busted in the news for all the violations and breaches and whatnot, and the government stepped in and said, you've got to get to AWS in, whatever, 12 months or something like that. And so because they didn't have enough architects and enough, SRE DevOps people to kind of make that happen, they had to give, developer teams access to AWS. And so a lot of them stood up Beanstalk, and now what they're doing is they're having to migrate off of Beanstalk, because again, it's just not where you stay, right? It's not one of those things. But the rest of this, so EC2 auto scaling, EC2 spot instances, which is just a flavor of EC2. This is storage, by the way, purpose built for EC2, not really used for anything else. And then we already talked about Lambda. The rest of this, and this includes AKS and ECS, those are all compute functions. Batch over here in the corner, by the way, is for batch jobs. We might talk about that at some point in time, but really it's really more on the like machine learning, batch processing, MapReduce, EMR, Hadoop kind of thing. But this one, by the way, load balancing is super important. So, you know, to highlight this in particular, with EC2, you pretty much always want to be using these, a load balancer with auto scaling with EC2. That's the trifecta. And if you throw CloudWatch in there, you've got the quad. But that's the trifecta that really makes AWS elastically like cost effective and scalable, is mixing auto scaling with a load balancer with CloudWatch. That's what makes all the magic happen. Because imagine if you could have a set of web servers that you could start with 2 because you need business continuity minimums, and it's 2 at 3 o'clock in the morning on a Saturday, and then Monday morning it steps up to 10, 20, 30, 100, and then at 8 o'clock at night on a Monday it steps back down to 2 because that's all you need because your load's gone down so much. This is what auto scaling in particular gets you in conjunction with a load balancer with EC2. So just remember that. I kind of refer to that as the secret sauce. If you're going to use virtual machines in production and you need to be able to scale those machines up and down in response to traffic, latency, or whatnot, load balancing and auto scaling are going to be your friends. And we're going to spend some time talking about that. So that's kind of a quick run through this whole like batch of services. But the most important ones are the EC2 related services, Lambda, and then ECS and EKS. Those are the most important ones. The rest of these, edge cases. Ask me questions at any time. They left out load balancing. Ugh, we'll get to it. It'll be part of this discussion or the scaling discussion. Okay. Most people do not know that AWS came out with, back in 2006. And the first service they actually announced, so this is a funny piece of trivia. The first thing they announced was actually SQS, but the first thing they released was S3. And they literally announced it and released it on the same day. And then SQS came out afterwards. And then we have EC2. So EC2 has been around the block for a while. Now, I got to tell you, like anything that AWS first releases, the first 6 months to a year, not the most stable experience. Honestly, I think they were just kind of getting everything together because it wasn't until about 2009, 2010, where all of a sudden we were like, man, this is awesome. This is stable. This is good, right? Things run fast. This is more efficient and better than our infrastructure. That's when you start seeing companies flip over. About 2012, they were like, whoa, we're flipping over. We're not going to run our own infrastructure anymore. We're going to use AWS for this. And then notice that ECS, wait, is that right? I don't think ECS came out in 2014, but you know what? Let's take them at face value. I suppose ECS came out in 2014, but I thought it actually came out in 2015, 2016, but whatever, nerd fight. Lambda definitely came out in 2014 because when Lambda came out and they were doing serverless, people were like, what in the world? Why would you launch serverless? It was way ahead of its time. And now people are doing entire applications in serverless. And especially with Kubernetes coming on the scene and adding its own version of serverless, people are really happy about it. And then, of course, Amazon starts adding its own specialized things like serverless, containers, and they start making their own processors. That's more of a marketing slide than anything. But it does show, by the way, that, cloud is now 16 years old. So it's been around for a minute. Not likely to go away anytime soon, but it might diminish in importance, but we'll see. I guess the other thing is that I said, I just said something interesting. I said, it might diminish in importance. It is assumed, by the way, that you have cloud experience in 2022. So, almost every company, consulting business, startup, medium-sized business, they assume that you have had some exposure to cloud and that you have skills in that arena. So you guys are definitely like getting into this space because it's considered a little bit of an afterthought. So as you come into here, it's great because you're walking into this mature community of a rock solid space, and you're not having to figure out all the pioneering, which is what was happening back in 2010. So now we talked before about managed versus unmanaged services. So just to frame this up, on the left-hand side, EC2 is a relatively unmanaged service. It is, meaning you're getting raw access to an operating system. You can log into it. By the way, who's responsible for patching that operating system? Is it the customer or is it AWS?
Customer.
Yeah, it's the customer. So make sure that's super clear. If you can log into it, configure it, then you are responsible for the security of that configuration. And if you can log into it, you're responsible for the whole thing. So if you can log into the operating system, that operating system is yours and is yours to own, yours to secure, yours to patch. So just be aware of that from a shared responsibility perspective. If you can configure it, you're responsible for what that configuration does. If you can log into it, you're responsible for the whole thing. If you, by the way, launch a load balancer and you can configure the load balancer, but you can't log into it, AWS is responsible for defending the operating system of that load balancer, not you, because you can't log into it. But if you punch a hole in the load balancer that says, I want to allow 443 traffic to come in, that configuration is on you. You're responsible for what that does. So just keep that in mind as far as when we talk about managed and unmanaged. It's like, what is your level of operational responsibility? EC2, high operational responsibility, high amount of control, high amount of flexibility as a result, right? But also higher amount of cost, right? So keep that in mind. ECS and EKS have two versions of their product. One is called EC2 launch type, and the other one's called a Fargate launch type. One is servered, right? The EC2 one is servered. You are responsible for patching those systems. If you launch an ECS or EKS cluster, and you decide to use the Fargate launch type, you are not responsible for the operating system because that's serverless. And by the way, when you hear the term serverless come out of my mouth, I want you to think about hidden servers. Doesn't mean it doesn't have servers. It just means that you're not responsible for them. So Fargate is just a flavor of ECS and EKS. I don't know why they talk about it as if its own product. It's not. It's just a flavor of ECS and EKS. So that's serverless. So now we're getting to more highly managed services. And then we get to Lambda. Lambda, the only thing you can do is control the runtime and put some code in there. That's it. So this is a highly managed serverless, like code executor, basically. It's a function, right? So at the bottom, again, EC2, highly unmanaged. You are responsible. At the top, highly managed, and you're responsible for very little except for the application. So AWS will promote this a lot because they want you to go up the tree. So when they ask you questions on the test, if you've got serverless as one answer, possible answer, and you've got EC2 as another possible answer, and they're asking you which one of these is the best, in AWS's mind, the best is always the highly managed option. Now, is that always best for the business? You know the answer to that. So it depends. Okay. So notice in terms of scale, by the way, Lambda over here on the right-hand side only has application code that you have to manage. Over here, you have data source and security and some updates and da, 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 da. Over here, you've got the clusters that you have to manage. And then notice here, it's like, you know, we've got everything. We've got it all at this point. Good. Questions? Okay. All right, so then let's talk about which EC2 instance types to use. Okay, so does anyone remember me using that? What was the term that I used at the beginning of class yesterday to talk about using something for what it was designed for? Does anyone remember what that term was?
Don't use a hammer as a screwdriver.
So you remember my example? That's good, Connor. That's good, right? That was a reference to mechanical sympathy, right? Because I think most of that started in the mechanical world, like in the physical world, not in the digital world. But it basically says, look, use it for what it's designed for. So here's the deal. EC2 has a bunch of like about 5 different flavors of virtual machines. Now, there's a wide range of numbers. It gets ridiculous, but also just know this, by the way, they will give you bare metal hosts. So if you want a 448 processor, 24 terabyte physical host in their data center, Amazon will let you buy one, and you can run a hypervisor on it and you can control it. So if you want control over the hypervisor, you can do that. So just know that we're talking about virtual machines. We're not talking about bare metal, but you can do that if you want to. So, then the question becomes, well, how do I know which flavors to use? So they kind of put the cart before the horse. So hold on just one second. Here it is. I'm going to come back to AMIs, so don't worry. So what happens is that when you go to choose an instance, so let's go back to the billing of the EC2 interface here. When I come in here and I want to start a virtual machine, it is true, by the way, that the first question that happens when I go, hey, I want to launch an instance, the first question it's going to ask you is, just whatever. It's going to say, hey, by the way, what flavor of operating system do you want to use? Like, that is the first question it's going to ask you. It's going to say, hey, do you want Windows? Do you want Mac OS? Do you want Linux? Do you want different flavors of Linux? Do you want Red Hat? Do you want Ubuntu? Do you want Ubuntu 2204? Sounds good. Okay, good. And then that, by the way, is an AMI. So I'll come back to AMIs in a second. But before we do that, I just want to talk about family types. Note, by the way, that when we talk about AMIs, I do actually have ARM-based or x86-based architectures to choose from. We're going to come back to that in just a second. But down here is where it's going to ask me things like, hey, what type, what size of virtual machine do you want to use? Now, if I click into this, by the way, this interface is horrible for seeing the sheer number of virtual machines that you could choose from. Now, I could click on compare instance types because they have revamped this recently, and they'll give you like kind of a better kind of like pop-up window, right? And so, you could come in here and sort by virtual CPUs if you wanted to. But I got to tell you, this is hard to use. So there's a website called EC2 instances.info, which actually just got bought by a company called Vantage. It was an open source project. So I'll just post the Vantage one in there. You can ignore Vantage. By the way, how do most of us know how to size a virtual machine? Like if someone comes to you and says, I need to stand up an Elasticsearch cluster. I need 6 boxes of this size. Where did they get this size from? Anyone know how we size these boxes? How do we size virtual machines?
Double whatever's requested.
You're not wrong. Let me just say that, Mike, you're not wrong. Why double whatever's requested?
Because they always go with like the minimum to try to go cheapest, but then they scrape the top of their CPU, memory, and storage all the time.
Fair enough. Okay. And where did they get their number from?
Their ass.
Yeah.
Again, not wrong. Okay. So, but let's assume there's some rationale beside it because you're actually correct, right? So they did guess about it, and you probably do want to add extra capacity just to be safe. But let's set those are all true statements. So let's set those aside for a moment. If we were in a logical, purely rational world, how would we actually size, for example, an Elasticsearch cluster? If someone said, hey, I've got 100,000 concurrent users hitting my front end, and 50,000 of those are going to be hitting the back end cluster, how would I then size my Elasticsearch cluster?
Using math. I mean, first you got to test it and figure out what's actually coming through. Now, how much are you actually storing in memory for every single connection session and object that you're placing in memory when they're connecting it? And it depends on what you're actually using. Is there throughput that's required after they actually connect, and what is that in between? Like it's a huge, right? Like it depends. Like, do they have any performance metrics at all to base that off of?
Right. In other words, you're either going to go off the vendor's pie in the sky vanilla guess about what their system responds to, like what their system needs for 50,000 users. Or to your point, Dave, is you're going to have to do some performance testing where you're doing at least a fraction of the load with the same kind of user behavior and hope that matches what they do in production and then extrapolate that out. So for example, it's 50,000 users, but you can only get your test suite to run 10. You might run 10,000 users against a piece of hardware, multiply that times 5 and say, this is the size of box that we need, right?
Mm.
Does that make sense?
Yeah.
Anybody find fault with anything I just said? Okay. So then what happens then is that from that kind of performance test, you would come back and say, look, I need 6 boxes and I need them to have 64 gigs of RAM and I need them to have 16 processors apiece. So with this website, you would just come over here and type in 64, right? And then you say, you know what? I actually need 16. Can I get 16 CPUs? And guess what? This would then list basically the systems that meet your requirements. Now, here's where things get sticky. If you don't know what the M family is, notice this says M on the left-hand side. I'm gonna blow this up a little bit, so I apologize. If you don't know what the M family is, or you don't know what the G family is, you're gonna go look that up, because just to say this, M stands for general purpose. It stands for median, not memory, median. So these are general purpose boxes, the M6A, the M5A, M5DN, and those letters all mean something. So Amazon classifies their boxes based on family types, and that first letter is the family type. So if it's a C, it's a compute instance. If it's an R, it's a RAM instance. If it's an I, it's a high IO instance. If it's a D, it's a data warehouse instance. Are they always that clean? Absolutely not. This is like a vendor on crack. There are 50 letters in their alphabet, but this is a good way for you to narrow it down and say, look, I need a box that has 64 gigs of RAM and 16 virtual CPUs. So you know that the M series is probably going to fit your needs, right? So if we go back to the slide here, this is where this starts making sense. That first letter is the instance family. So C is for compute, R is for RAM, M is for general purpose. T is also test, but Amazon sometimes refers to that as general purpose. The number, by the way, is going to change. It could be a 5, it could be a 6, it could be a 7, it could be a 3. It just denotes the latest generation of that family type. Why do you care? A C6 is going to be faster and cheaper than a C5. Every time Amazon releases a new generation of box, it's typically faster and cheaper than the previous generation. And then the N or the DN or the I or whatever comes after the number, those are attributes. Nobody memorizes those. So those are not going to be ever on your exam. No one's going to ever ask you what a DN is or a D or a G. No, they're not going to ask you that. So you don't have to memorize the attributes. And the t-shirt sizes, the instance sizes, well, that's going to make sense to you. Why? Because you know that a medium is larger than a small. You know that a large is larger than a medium. You know that a 2x large is larger than a large, right? You know this, right? Alex, do they ever run out? Like if you want a certain box config, would ever be available at that time? The only time I've ever seen that is if you want a really large box, like a 24x large, like a C5 24x large. If you need a really large box, that's when you could, if you don't have a reservation, I know this sounds weird, like you're going out to dinner, but Alex, if you don't have a reservation with AWS for that box and you go to request it and you want to do on-demand pricing, which is just retail pricing, off the street pricing, and you ask for a 24 extra large box, you may not get it because you don't have a reservation. I got to tell you though, that even with the large boxes, that's rare. So you don't usually run out. Now here are the family types. So notice that the M series, so notice the M's over here under general purpose, left-hand side, right? Notice that the M series is over here. And then notice that I've got the T's, and we've gone from T2s to T3s to T4s. And then by the way, the Macs are over here. By the way, does anyone actually run Mac as a server in production? I don't know who asked for that, but I'm very curious. Anyway.
It's useful for a number of things like building other Macs and setting up automation for them.
Agreed, especially for end user computing, right?
Yeah.
But just so you know, there is an end user service. It's called Workspaces. So I'm really confused by this server play actually. But I take your word for it, Dave. I don't think I know enough about the.
It's more of an internal thing. Yeah, it's so we have a whole Mac team dedicated to that, and they manage it, and that's one of the reasons that they use that for actually managing it.
That's good to know, actually. Thank you for telling me. I was kind of curious. I was like, what's the use case for that? I've had other design teams tell me they use it for 3D rendering because the Macs are apparently particularly good at that, and for other graphic design tasks. So notice, by the way, that the general purpose boxes, which either starts with an M or a T, have a 4:1 ratio of memory, right? Notice that the R series, and I'm going to call out R. Yes, I see that there's X's and Z's in use. Those are edge cases. Most people don't use those. Notice that the R series has an 8:1 relationship of memory to CPU. And then I've got storage optimized, which is the I's and the D's, right? And by the way, those are usually really big boxes. Like they have like at least 64 gigs of RAM, sometimes 128, 256, etc. The ratios though vary, so they don't say the ratio there. And then the C series of boxes, so C5s, C6s, I think they've got C7s now. These are all compute optimized. Notice there's a 2:1 relationship of memory to CPU. So 2 CPUs, 4 gigs of RAM, 8 CPUs, 16 gigs of RAM. And then last but not least, out of the families is accelerated computing. This is usually your G boxes and your P boxes, and they've got P2s, P3s, P4s. I don't see people using the Fs and the M's a lot. This is all accelerated computing. These boxes have GPUs in them. They are used primarily for machine learning and for 3D rendering. So all of your SageMaker instances for the machine learning are probably going to be some variation of this box. I do want to point out, just as a side note, that Amazon has what they call elastic inference video cards that can be attached to any of the instances. So you can attach anywhere from 2 to 24 video GPUs to a box, regardless of whether it's in the accelerated compute family or not. But just know that the accelerated compute family comes with GPUs. So to restate this, general purpose is a 4:1 ratio of memory to CPU, average processor, average memory, median, right? Memory optimized boxes are for memory high boxes, boxes that you need a lot of memory on. So they're 8:1 on the ratio. Compute optimized are usually provide access to a raw processor, but they're 2:1 on memory to CPU. And then storage and accelerator, just dedicated platforms for storage optimization and for GPU optimization. Okay, Alex, that's the other use case where you might not get access to a box. If you're asking for like a P4DN, like 8x large, they may not have any available depending on who's running them down at the time. Again, I very rarely hear now of anybody running out of capacity. Amazon is so far ahead on the capacity hardware boundary thing that it's been a while actually since I've heard anybody complain of like I couldn't start these boxes. So, but again, reservations can negate that. If you buy a reservation with Amazon, they will guarantee that you have 100% access to a box at all times. So, okay. Questions about the family types: general purpose, memory, storage, compute, or accelerated.
Is it important to remember the different types for the exam?
Yes. I don't need you to memorize all the prefixes. I don't need you to memorize the generation numbers. I don't need you to memorize the attributes. I just need you to know that these 5 family types exist, because they'll say things like, hey, we were running boxes with memory optimization. No, they'll say, like, there'll be a question, it'll say something like, we have a machine learning workload that we want to run, and we're looking to optimize it by running on systems that have GPUs. Which of the family types would you use? Answer is accelerated computing, right? So they will ask you questions like that. But Amazon, and I got this straight from training and certification not even 3 weeks ago, will never test you on numbers that can change. So they're not going to ask you about exact pricing, and they're not going to ask you about generation numbers for CPUs either, or like for computers, instance types. Okay. Good. All right, let's go back to AMIs. Was there a question?
Yeah, would there be a question where they're like, I don't know, they're considering like a T for like a high GPU thing, and you're supposed to like recognize that that's not the right letter for that like family or something like that?
They are more likely to do that on the system operations exam, but not on the architecture exam.
Okay.
On their operations exam, they will sometimes say, hey, you're running the T series and all of a sudden your CPU usage goes from this to this. And then what they're testing is that, do you know that the T series actually is CPU bound? Meaning that the T series, you can actually use the CPU for a certain period of time, and then you run out of what's called CPU credits, and it'll constrain you back to like 20% of the CPU.
Got it.
That's why I call the T series the test series, and Amazon calls it general purpose. So that'll be on the SysOps exam, not on the architecture exam. Okay, so let's go back to the AMI piece, right? So AMIs, as you saw when I was actually in the interface, you saw that one of the first questions it asked me was, I'm good. Let's go back to launch an instance. Was that it asked me, hey, which AMI do you want? Now, I just want to say this. Most enterprises do not use Amazon's plain like standard AMIs. Most enterprises roll their own AMIs. Some people use Packer, which is the kind of like standard tool for this. Amazon does have EC2 image builder, which I think is about a year old now, maybe a little older than a year. It's not a great product from my perspective, so I'll probably just stick with Packer. Give it another year or two, and it'll be a great product, but it still needs some work. But you can, you could obviously you could import these out of VMware if you want to. There's tools for doing that. If you already have your own, go images inside of VMware, like a VMDK, and you want to convert it out. Just know that most people will use Packer in conjunction with Ansible or Chef or Puppet or something else to build the image, output the image, and then push the image to all of their AWS regions, so that they can have their particular hardened, secure, operationally customized images available for people to use. So these are quick starts. If you want to grab AMIs from some other location, like I don't think I used to have AMIs in here. Maybe they're in Ohio. They're probably in Ohio, actually. If you create your own AMIs, they just show up here. Most people do, first of all, do not use the community AMIs. If you have a relationship with someone like Microsoft or whatnot outside of AWS, if you want to, use their AMIs, you can. Again, most people don't do that. And then the quick start ones are all managed and set up by AWS. So they've all been scanned. They're not hardened, but they do include things like, especially if you use the Amazon Linux, they include things like the CloudWatch is already installed, the CloudWatch agent, or CloudWatch logs is already installed, or the systems manager agent is already installed. So make sure you know what you're doing, because if you're not familiar with the image and you didn't write it yourself, you have no idea what's on there. So be careful. If it's your account though, and you're just messing around, don't worry about it. Just use the quick starts. Just don't use the community AMIs. So this is just an image. This is just a bootable snapshot that gets copied onto your C drive or root drive if you're using Linux, right? That's all this is. And so what happens is that when you go to create an EC2 instance, you have to choose the bootable AMI that you want to use. And by the way, you can launch 50 virtual machines, 100 virtual machines off that AMI. You do have to do some customizations though if you want that AMI to hook into like Active Directory or have its own unique host name or whatnot. So just remember, AMIs are where most of the magic happens when it comes to virtual machines, just like container images are where most of the magic happens when it comes to containers. A lot more and more people are getting to what they call immutable infrastructure, where they're using AMIs to redeploy their services instead of making changes for running systems. So just like with Docker or container images, how you redeploy container images every time you want to change the software, people are more and more starting to do the same thing with AMIs, where they're redeploying their web servers, they're redeploying their app servers instead of making changes to running systems, because they don't want to log into these boxes anymore. So just know more and more people are not logging into servers unless there's, some kind of weird one-off situation to do so. The reason that they're focusing on AMIs is because your boot time, you can get these systems to boot in like 10 or 20 seconds. Now, obviously that varies depending on how much configuration you're doing at boot time, but that's why they're trying to put it all in the AMI. If you're not doing any configuration at boot time, there's literally boxes like, just to say this, I wonder if Cloud9 is active. Let me just check this really quick. Let me just show you this really quick. I think I have one in Ohio. Let's go take a look. So this is a box that I frequently use to run workshops and whatnot, right? This box is shut down right now. If I go and click on Open IDE, it's going to go find out that the instance is stopped, and it's going to go start the instance. Now, currently 7 seconds have passed since I clicked that thing. We're now on 10 seconds. We're now at 15. Now we're at 20. 20 seconds for that box to boot with the configuration, with everything necessary to get that thing running, right? 20 seconds. So this is why you want to do everything in the AMI as much as possible instead of relying on configuration at boot time. Because if you're responding to a failure, you want these boxes to boot as fast as possible. You want to sit there and wait for 5 web servers to start and then take 10 minutes to do it while you're having an outage, because that's your standard boot time for a web server. Imagine having a 20-second, 30-second boot time for a web server because you're in crisis and you need to get this thing back up. Now, I want to throw this caveat out there. As we all know, that databases can't do this because you got to restore the database, especially if you're starting from scratch. But all other stateless systems, you want to focus on putting everything in the image as much as possible. So that's really what the AMIs are for, is there are these images that you configure that contain everything you need to get the system running, except for maybe like little tiny things like host name, maybe hooking it into an LDAP server, that kind of thing. Now, we already talked about where you get your AMIs. Create your own is really the answer. You know, Amazon has pre-built ones. Don't use the community ones, but for the most part, you're going to be provided with AMIs by your enterprise, but you want to write your own. And the name of the tool by HashiCorp is called Packer. And Packer will hook into other configuration management tools. So, you know, use Packer to build your images as much as possible. I think we talked about that already. Amazon, by the way, does allow you to put what they call instance user data into your bootable system. So when it boots, you can actually have some commands run. User data can be very powerful, but again, most of the time you don't want to use user data because you're going to be doing configuration at boot time, which we don't want to do. We don't want to do configuration at boot time. We want the barest minimum of configuration. But if you do need to do configuration at boot time, user data is going to be helpful. User data is almost like a text space where you can stick in just a series of either bash or PowerShell commands, and the system will actually execute those commands at boot time. It's based off of an old technology called Cloud Init that Ubuntu came up with like a long time ago, actually. Well, Ubuntu and I think Red Hat actually both came up with it. This is honorable mention for the EC2 image builder service, which actually just needs some work. So I don't think this shows up on the exam, at least not that I've seen, but you start with an image source like Ubuntu or Red Hat or whatever. Tell it what you want to install, define your custom tests, and then it distributes things out. My problem with image builder is that it doesn't have all the custom options that you need for enterprises. So it's not quite there yet. But just know that the service exists.
Is this an alternate approach to using Packer?
Yep. You could use this instead of Packer, but Packer has a lot more flexibility.
Got it.
Yeah. Plus, this won't integrate in with Ansible or Chef or Puppet or any of your other configuration management systems. So, I mean, you can get it to do that at boot time, but again, we're trying to avoid that. So I would say you'd be better off just sticking with Packer if you're going to do that.
Yeah.
The other thought to have is that your virtual machines actually do come in 2 different general flavors. The default is that you are on hardware where there are other customers, but you can't see the customers. They can't sniff your packets. They don't even know you're there. You can't see each other's memory information. You can't see each other's networking information. You can't see each other's CPU information. Amazon uses, you can't even really call it Zen now. They use a Zen hypervisor because they also use this thing called Firecracker as well. But they've customized the Zen hypervisor so heavily that it looks nothing like the open source Zen anymore. But you're on a shared piece of hardware with a bunch of other customers. Now, if you either have licensing or security requirements that require you to be on your own dedicated piece of hardware, Amazon has two options where you can be like, hey, I want a dedicated host, which means you have the whole host. It's yours. You're paying for it. You can put as many virtual machines on there as you want. Or oddly enough, Amazon will slice out, like partition up a host and say, well, this dedicated like set of hardware on this host is yours and yours alone. You're not going to move anywhere. You're the only one who can use it. You're the only one who can boot to it. Your hardware ID isn't going to change, but you actually kind of like are on with other customers, right? That's a dedicated instance. So just be clear that dedicated host and dedicated instance do both have isolation, like hardware isolation, but dedicated host has a deeper level of hardware isolation than that. No other customers are on there. With dedicated instances, what they're doing is, does anyone ever work with like old AIX or HP systems where they had LPARs and virtual partitions and they could actually physically isolate like hardware through software? That's what they're doing with dedicated instances. They don't talk about it a whole lot. You're going to kind of like go after them to get the details, but they're basically isolating that virtual machine to its own dedicated set of hardware. Dedicated instances and dedicated hosts are the most expensive way to use AWS. So really you only use these if you absolutely have security and licensing requirements that require them, right? Elias, what do you say? How do you want to confirm what they are claiming is correct? Can you clarify that for me?
Said, hi, can you hear me?
Yeah.
So yeah, you said like they have two options, even they give us something shared or we have like the whole host, like dedicated one. Do we have any kind of like strategy to confirm what they are claiming is correct? Or when they say we have this one for us only, let's say for our company, it's 100% true.
Well, when you get control of the host, you can actually see everything on the host.
Mm-hmm.
So you get partial like hypervisor access to see who all is there.
Okay.
Now, could that all be simulated?
Mm-hmm.
I don't know.
Maybe so.
It could be, right? Because
So-
they're not going to give you access to a data center. So you do have to trust them, right?
Okay.
But the one thing
So-
you can tell is when you compute the hardware ID, it doesn't change, no matter how many times the system's rebooted.
Mhm. I
So,
see.
yeah.
Okay.
So there's a little bit of trust there. We already went through the instance types and the families, so hopefully this makes sense. So again, that website that I shared with you, ec2instances.info, notice by the way that you can actually see like different regions if you want to. You could switch it off, you know, if you wanted to like key off of different characteristics. Notice that there are reservations listed here, but like let's just take a moment just to take a look at specific instances, just get a feel for pricing. If I look at the T3 series, which there's the T3, what's the new standard here? Small, nano, micro, medium, large, extra large, 2x large, etc. Right? Notice that if I want a 2 CPU, 8 gig system, that it's going to cost me about 8 cents an hour. So 2 gigs, 8 gigs of RAM, two processors, 8 gigs of RAM. Now, there are some caveats with the T series, which I think I've mentioned before, but you know, just something to keep in mind. Notice that this is 8 CPUs and 32 gigs of RAM. That's going to cost you about 33 cents an hour. That's on demand, by the way. That's the second most expensive way to use AWS. That's retail price. If you decide to get into a year or 3-year commitment with Amazon, that price, like this is a year with no upfront, that price drops 13 cents to 20 cents an hour. So, you know, you're gonna spend $1.20 a day or something like that. Is that right? No, that's not right. I don't know where my head's at. You spend like $12, I think, right, to get this working. So just something to keep in mind is that these prices are actually relatively cheap, especially considering that you can spin these instances up and give them back. So it's not like you have to keep them running 24/7. There are obviously a lot of use cases where you are going to actually keep them running 24/7, but for what they offer, it is surprisingly cheap. And performance is pretty consistent. Let's take a look at the M6 series. Or actually, that was the M5. Notice this is a 24 extra large with 96 CPUs and 384 gigs of RAM. Retail, this is going to cost you $4.06 an hour. Sorry, $4.60 an hour. Notice if you get a reservation, that price drops tremendously down to just shy of $3 an hour. So $36 a day. Remember though, this is highly redundant enterprise system, right? If it happens to fail, it's going to reboot, and of course, if you run a pair of them, you're going to meet best practices and have it highly available. So might say, you're not going to get woken up at 3 o'clock in the morning if a disk fails, because you're not even going to see it. You're not going to even see it if a CPU fails, unless the operating system hiccups. And then what's going to happen is just going to restart the OS and bring the whole thing back up by default. You are going to miss so many hardware failures using EC2. You might see them in the logs, but for the most part, you won't even see a blip on your system. And a reminder, like you just saw me looking at the M5s, there is actually an M6 series, but it comes with all these suffixes like I for Intel, A for AMD, G for Gravitron with disk attached. So the M6s are cheaper and faster than the M5s. So they always want you to be using the latest generation of boxes if possible. So notice this is an M5 compared to an M4 at the bottom. M5 is cheaper. Now, AWS does have a couple of tools that come with this whole space. For example, there's the compute optimizer, which will basically, what it does is it looks at all of your instances, and you can select auto scaling groups or EC2, individual EC2 instances. And what it will do is it will basically take a look at your consumption and say, hey, these are all optimal. Like these are being used efficiently. Your TCO is good. Your ROI is good. And these, by the way, are not great. So they'll come back to you and say, hey, you've got 5 boxes here that are 1% utilized. Why don't you shrink those down to these boxes and you can save $1,000 a month? So Compute Optimizer will make very specific recommendations to make sure that you are aware that your fleet is either optimized or unoptimized. So just know this is something that you can easily just enable. There's no cost for Compute Optimizer, and it will just go in and give you reports about what's going on with your fleet. Now, when you are manipulating these virtual machines, they come in a couple of different states. So obviously when you first launch, it's pending. It's like starting basically. And then it'll go into a running state. And then if you decide to shut it down, what will happen is it will, you're terminating it. It'll go to a shutting down state and then it'll delete itself, right? Obviously there's also rebooting, which doesn't really affect anything. It doesn't move the hardware around or anything like that. It doesn't deassociate any disks. Now, what's funny is that if your instance is backed by a persistent disk, which is by default how everyone recommends that you use AWS, is that you actually use what's called EBS backed instances. This is the default recommendation, by the way. You can actually stop that box, and the only thing you'll pay for is storage. You won't pay for compute, memory, or networking anymore. You won't pay for the box. So some shops at Friday at like 7 o'clock at night will stop their development environments if they're not doing a follow the sun model, shut the boxes off, and then restart them at 4 o'clock in the morning on Monday morning. And so the non-production environments are actually not running over the weekend, which, technically saves them about 3 days worth of work, right? Because you got Friday to Saturday, Saturday to Sunday, and then Sunday to Monday morning. So just know that is the standard recommendation is that you use EBS backed instances. You do not use what they call instance store backed instances. So these states, by the way, are questions that mainly pop up on the system operations exam. They do occasionally ask you, like, what happens if you try to terminate an instance that doesn't have a permanent disk? Well, the answer is that everything's deleted because it doesn't have a permanent disk, right? So they will ask you really simple and silly questions like that, but they will actually test you on these states when you actually do the sysops exam, if any of you decide to do that.
Is the persistent storage saved as like a snapshot somewhere?
Well, it actually, think of it as like more like it's a hard drive. So it actually persists on a separate storage system that is presented back to the compute system. So like it has a separate life cycle separate from the virtual machine. Now, if you
Okay,
want to
yes.
snapshot it, you can. So you can actually snapshot it and put it into backups, but when it's live, it's actually sitting on the storage subsystem. And we'll cover that when we get to storage, but EBS, the Elastic Block Store, it's a live storage system, and it provides super fast disks, like ridiculous speeds, like 256,000 IO per second for some of these disks at a 256K chunk size, which is incredibly fast. And these disks are persistent, but you can back them up to S3 if you want to. They call them snapshotting. And so you can take as many snapshots as you want, as long as whatever you're willing to pay for. But that takes it then off of the EBS storage system and puts it onto a backup system. Good. Okay. There we go. So I mentioned this before about user data. When you boot a system, when you like launch one, if we go actually back to look at where we were launching before. Let's say we come up here and we launch an instance. We're in Ohio. I actually have templates in Ohio. Let's say we're just like doing a test box, and I'm gonna stick with Amazon Linux this time. Sticks with x86. I'm not gonna switch to ARM. Let's leave it to a micro. I do have a key pair. Here's my network settings. Here, by the way, is where you configure storage. Notice that this is EBS storage that I'm configuring right here. This is like permanent storage. This particular T series boxes, they don't come with what they call ephemeral storage, instant storage. So there's nothing to configure here. But if I wanted to, I could do things like as I scroll to the bottom. Where are you? I could actually stick, I could actually stick, like commands in here if I wanted to do whatever, like, I was looking for, right? So like you could hook this into Chef or Puppet or Ansible here if you wanted to. So if you want to do some configuration at boot time, or you could actually just paste a whole shell script in here. I could actually call a script that downloaded a script, a script and put it into the system if I wanted to. User data is for commands that you want it to run at boot time. That's what it's for. Now, notice that, by the way, that there was a bunch of other options I could select. Like there's a bunch of other, I could go to dedicated tenancy versus dedicated host. I could ask for a capacity reservation, which I don't really have. I could, there's a bunch of other like options here. The main thing to know though, is that with user data, I can actually configure the system to do whatever I want at boot time. You want to avoid this, as I stated before, avoid this as much as possible. Do not make this a super heavy user data script, because while it's cool to configure things at boot time, it also slows down the boot process. Put it in the image. If it's something that you can put in the image, don't put it in at boot time. And the last thing is that if you're on a box, you can actually curl this 169.254.169.254 IP address with the /latest/metadata, and you can actually get information back about your system, right? So let's see. let's see, what were they giving the example? Public host name. Wonder if metadata is enabled for this, but let's see what it does. Wow, they're just failing entirely, aren't you? I wonder why it's having an issue. Not sure why that's not working. But it is slow. Anyway, what it would normally do is it would actually normally return back like the specific like value of public host name for the box in question. I'm sure I did something to this box that's making it not work. It also might require authentication because I'm actually using host credentials on this particular box. But if I put like public IPv4 or public IPv6, or if I put private IPv4 or private, there's a whole host of metadata that I can actually put into scripts to retrieve off the box. Now you have to be logged into the box that you wanted to retrieve the metadata about for it to work. Obviously, in my case, for whatever reason, the demo didn't function there. But any of these names like MAC address, instance ID, public IPv4, local IPv4, I can actually grab those just right off the wire by like doing a loop back against that 169.254 address. They will ask you questions about, hey, I need to grab inside of a script my IPv4 address from inside the operating system. What can I use to do that? Well, obviously my bad demo notwithstanding, you would normally be able to use curl for that. So you can just do a curl space dash s and then, you know, the URL to grab the data in question. I have to admit, I am curious. Oh, so you are working.
Is it because you're trying to go over HTTPS instead of HTTP?
You know what? That's probably it, actually, because I just probably had a brain fart. That's exactly right. I bet you that's it, because normally it would just return. I don't have a public host name, but how about? There we go. Yeah, that was probably it exactly, actually. Yeah, because I put an S in there by default. Thank you for catching that. I was like, man, why isn't that working? So this allows you basically to grab the metadata that you want from the system. Let's try host name. Huh. There it is. It's just not putting a new line on it, right? So here it is catching the information. So IP72. So do note, by the way, that whatever, remember how I said like you can never really get rid of IPv4 whenever you use, even if you're using IPv6. Part of that also is that your EC2 boxes will always have an IPv4 IP address, and they will have a DNS name based on that IPv4 address. So in this case, actually, it's actually based on the IPv4 address that it already has with US, you know, and obviously it looks internal, right? With us-east2.compute.internal. So this then would allow you to stick that information inside of a script, do a loop back against it, pull it down, iterate upon it. But this way you can actually get the configuration information of the instance from inside the instance. So user data and metadata are questions that are predominantly asked on the sysops exam, but they will actually test and see if you know that this URL can be used to retrieve information, right? Particularly the portion that says 169.254.169.254. All right. Then the other thing is, and we touched on this before, is that when we were talking about IAM, you can actually you can jury rig it so that IAM can be used to log into your boxes. But that's not what works by default. By default, you have to use these private and public key pairs in order to get this to function. And think of the public keys as like the lock and the private key is like the actual key. So anytime you launch a box and you say, look, this is the key pair that I used, what Amazon does is it takes the public key and it sticks it on all the boxes. If you're used to using a configuration manager like Chef, Puppet, or Ansible, you probably use something like with Chef, like encrypted data bags, for example, to take your keys and put them out there on the box and make it so that you could actually use your private key like, pull it down and grab it locally so you can use your private key to log into the system. So a lot of Amazon functions off of a passwordless kind of environment. Because, as for the most part, they don't want you logging into boxes. They want you to configure them remotely. And that's pretty accurate. Back in 2014, me and the crew that I typically run with, we, even back then, we remember the first time we actually ran an entire, 2000 box infrastructure and nobody was logging into the boxes. We were all doing configuration management, infrastructure as code, and running the boxes, without having to log into them. Every once in a while, we would log in to do forensics or to figure out why there was a pattern of failure. But for the most part, if a box failed and it was part of a set of 20, we would just kill that box and restart it because we just assumed that it was a cosmic ray or something weird happened, which is actually pretty accurate, especially for non-web exposed boxes, right? Now, if 5 boxes failed out of 10, then we assume that there's maybe something wrong with the configuration. Then we would log in and take a look at it. To do that, we'd always use our private keys to log in against our public keys. Now, in the console, when you go in and look at EC2, for example, you can see down here that I can actually choose, actually it's not down there, it's up here, where I can actually choose my key that I want to use. And here I chose one that I had already configured. If I want, obviously I could create a new key pair. Be aware that people are moving more and more away from RSA and over to the ED25519. Key pair type. Windows doesn't yet support this from an AWS perspective. And note that if you're using OpenSSH like Git Bash or whatever, you just download a PIM file. If you're using PuTTY, you can actually just get a PPK file to do it natively. When you create this key pair, just to make sure it's clear for me later on, when you create this key pair, what will happen is that it'll automatically download the private file. So notice that Firefox is already getting the private file and putting it on my system. If you delete that file or lose it, you can't get it back. You have to recreate another key and then update that key on all the boxes that you're connected with. So notice here it's using delete me because it assumes that I just downloaded the PIM file, the private key for the delete me file, right? So here at this point, by the way, having answered like most of the questions, we could actually click on launch instance, and it would basically at that point launch the instance in question. And you can actually just sit here and watch it, go from a pending state to a running state as it, runs through its whole spaces. It will do a status check. The first check, it checks the virtual hardware. The second check checks to see if the operating system is up. It is not checking to see whether or not your application is up. So it's not like a readiness probe, right? It's not actually checking to see if you're able to take traffic on the port in question. Another aspect to EC2, other than the tagging and the user data and the metadata and all those pieces, is that having an enterprise-wide tagging strategy for your cloud is incredibly important, especially if you ever want to do any reporting or any billing or any dimensional analysis against your systems. You have to implement tagging. And this is relatively easy if you are doing infrastructure as code, because you can just put tags into what's generated. But if you're doing things manually, it can be really hard to get people to adhere to the policy. So as a general rule of thumb, having some tags is better than having 0 tags, and having a few tags is better than having a lot of tags. But I would say this is that I've been in environments that have 30 or 40 tags on every system, and you can find the owner, the billing code, what the box, when the box is supposed to be deleted, what version of software it's running. You can't really overkill it unless the tag is meaningless, right? It's not useful for anybody. So EC2, by the way, also has this concept of what's called launch templates. So if you are consistently launching the same types of boxes over and over again with the exact same configurations, you can actually create what's called these launch templates, and they're like YAML or JSON defined templates And what's cool about these things is that you can actually just call the template instead of having to call like an entire, like all the parameters and all the little features of a box. What size box am I using? How big is the hard drive? What type is the hard drive? You know, what's the key pair? If all that's already predefined, then you can just call the launch template. I think in my Ohio instance, I think I have a launch template. Yeah, this is for my Ubuntu lab, although I'm not sure that I've updated this recently. But this contains like all the like details that I wanted it to have at the time. Include definitions for storage, any resource tagging, which I didn't have in this case, any, if I had extra network interfaces or any kind of other advanced details. Notice that most of that I just actually left blank. I was really just wanting to start multiple instances of this size with this key pair name at the time. So when you launch this template, all you need to do is just call the template and say, I want to launch EC2 with this template, and it basically answers all the questions for you. So launch templates can be very useful for codifying your processes for launch, especially as it relates to auto scaling. You know, creating fleets of instances can be incredibly useful. Any questions about AMIs, EC2 family types, user data, metadata, any of the pieces that we just covered for EC2?
Yeah, I want to go back to something that you said, and I just want to reiterate it to make sure I understood it correctly. Did you say that more and more people are moving towards the pattern of using AMIs and launching AMIs as opposed to building Docker images and launching them? Is that correct?
No, not in lieu of Docker images, in addition to Docker images. So you know how Docker creates immutable infrastructure because
Yep.
you don't actually change the, people are taking that same immutable infrastructure pattern and they're applying it to virtual machines. So think of it as it being done in tandem, Rakesh. People are no longer wanting to change a running operating system. What they do is they change the image and then launch a new version of the operating system.
Understood.
So it's not in lieu of, it's not a replacement for Docker images. That's not what's happening.
Okay.
What's happening is that immutable pattern that Docker made popular, are using that same pattern for their virtual machine images.
Understood. Okay.
Yeah, because what people are finding out is that tracking changes for running virtual machines is a real pain in the rear end. But if everything's done in code at image build, then you've tracked every change you've made against that virtual machine. Just like you would in it with Docker, right? You could actually literally look through 10 revisions of history on a container image and see every single change that was made to that container, because you don't change containers while they're running, right? You change the image and then redeploy them.
Yep.
Yeah. So sorry if that was confusing, because then that would basically, if that's what the impression I left you with, then I was basically saying, well, you know, virtual machine images are making a comeback and they're going to replace Docker images. No,
yeah,
that is not happening.
That. Yeah.
Yeah. So thank you for clarifying, because if that's the impression I left you with, that would be patently wrong. So good. Other questions? I think we should take a break. I think did I mention that the pace of things, the knowledge was going to get a little bit more intense today? I think I mentioned that. So I think I've been throwing knowledge at you for a little bit. We need to cover basically these last few options around pricing, which, you know, is pretty dense. These last options on instant storage, which again is just a rehash of some things that we've already talked about, some volume type characteristics and whatnot. And then we need to talk about high performance computing, just the fact that there are options for high performance computing, including network adapters and some other pieces. And then the last thing we're going to cover is just like a plug for Lambda, just to basically to, you know, how serverless computing works. And then we're going to roll into a knowledge check, and then we're going to do, you know, your next lab, which is really where we want to be at this morning. Okay. So does anyone have any burning questions? Otherwise, we're going to take a break. Okay. All right. So let's say it's 11 o'clock. Come back at 11:15. We'll take a 15-minute break, and we'll continue on with the rest of our EC2 discussion. Okay. See you in a bit. Okay. Welcome back. We're going to talk about pricing options next. Any lingering questions from the last topics before we go forward? Okay. This is all in the realm of virtual machines, so we're still just on the topic of EC2. This is the longest module, by the way, in the entire course. So, yeah. So let's talk about the different pricing options. Here's the main things to remember is that we mentioned before that dedicated hosts and dedicated instances are the most expensive ways to use AWS. And then you have on-demand instances, which are on the right-hand side, like in gray. Those are the second most expensive ways to use AWS. That's because that's retail pricing. You are not in a relationship with Amazon. You are not committing to paying anything, and there's no complication to it. You ask for the resource, they give it to you. When you're done with it, you give it back. Most billing inside of EC2 is per second billing. There is per hour and per like chunks of hours billing for like Mac boxes, although I think they recently converted to per second, but don't quote me on that one. I think that might still be like per hour, but I think they were moving to per second with Apple. But like Red Hat and SUSE are going to be per hour billing. But if it's, you know, Ubuntu or Amazon Linux or some other free variant of Linux, those are all per second. So if you start the machine for 20 seconds and you shut it off, you're going to pay for the duration it ran, which is, you know, 20 seconds, whatever the shutdown time is, right? That's on demand. The other three options, as far as reserved instances, savings plans, and spot instances, well, two of them kind of go together. So reserved instances and savings plans kind of go together because they're both 1 or 3 year commitments, not 2 year, but either 1 or 3 year commitments. And the difference is that savings plans usually come with a lot more flexibility. And it's a little weird because with savings plans, you actually give Amazon money. You're like, Amazon, I'm going to give you $10,000. And what they'll do is they'll then give you like $16,000 worth of compute. So you get more like value for the dollar if you pay Amazon up ahead of time. That's what they do. But your money expires after a year or 3 years, depending on which option you chose. And by the way, there's savings plans for EC2. There's savings plans for just compute in general, which could include ECS, EKS, and Lambda. There's also savings plans for SageMaker instances, which is machine learning. So just keep that in the back of your head. Even though this is ostensibly about EC2, savings plans do far more than just EC2. Reservations are very similar to savings plans, but instead of giving them money up front, you're giving them a commitment up front, which says, you know what, Amazon, I will buy 5 reserved T3 micros in Virginia Data Center 1, so US East 1A. I'm going to buy 5 of these T3 micros, and I'm going to commit to paying for them for a year, whether I use them or not. That's what a reserved instance is. Those also known as reservations, by the way. Now, you might say, but Michael, what if I'm not using those boxes? Now, I got to tell you, I can't even tell you how many times I've sat in the CTO's office and had the conversation of like, you know, you want to migrate off this project in the next, 12 to 18 months. Let's just go. It's going to take us at least 12 months to get everything ready. Let's just go ahead and buy a reserved instances for these systems that are part of this project. Because I've never seen a migration project go under. I've seen them go overtime. And I can't tell you how many times I've been in the CTO's office and been like, remember that discussion we had about getting reservations? And the CTO's like, yeah, we should have done that because it took us far longer to migrate that project than we thought. So just be aware that you need to know what the life cycle is for your particular product in the servers that it sits on. But reservations are ways for you to say to Amazon, I will commit to either 1 year or 3 years of paying for these boxes no matter what. In exchange, you're going to give me up to like a 72% discount, if memory serves correctly. So reserved instances are where you give Amazon your word and you like sign a contract, like you commit to paying for these boxes. Savings plans are where you give Amazon money and they give you fun bucks in return that are far more valuable than the money you gave them, right? So those are kind of two sides of the same coin. Savings plans, just remember this though, are far more flexible than reserved instances, because with reserved instances, you're going to say, I want to run this type of machine in this region at this availability zone with this operating system. And it's really hard to change that. Like you've got to go through some hoops to change where you're going to get your discount. So things to keep in mind. Spot instances in purple right there are the most unique of the discount types, because this is where Amazon has extra unused capacity. And they're saying, look, instead of charging you $1 an hour, you come back to Amazon and say, look, instead of paying $1 an hour for that box that's normally $1 an hour, Amazon, if you have so much extra capacity, I will give you 40 cents on the dollar for that spot instance if you give it to me. And here's what Amazon does. Amazon will give you the spot instance, but if someone comes along and says, I'll pay the full $1 for that box, they give you a 2-minute warning, they shut the box down, and they give it to the other customer. So when you agree to use spot instances, you need to only do that with applications that can withstand interruption and that write their data out at least every 60 seconds, every 2 minutes. So you can only use spot instances with like reporting applications, batch applications that can write their data out pretty frequently, things that checkpoint their progress. Amazon has made that a whole lot easier than it's ever been, because you can actually, for example, run web servers in what they call these fleets of spot and on-demand instances. And Amazon will literally give you spot instances for your web servers. And if for some reason they run out of spot instances, you will automatically spin up on-demand instances to handle your load. So just know that there are tools to help you use spot instances really easily, but spot instances do require applications that are either stateless or can withstand interruption. So kind of fun. There is a great workshop, which is part of the workshop list that I recommend that you do for free. It is called, I'm going to pull this out of memory, so let's hope this works. Oh, never mind. It's in my history. We don't have to rely on my faulty memory. It's called ec2spotworkshops.com. If you have never done this workshop and you've never touched either auto-scaling or SpotWorks instances or containers or, there is so much fun stuff in this free public workshop that I could not implore you enough that after you're done with this class, put this URL on your list and go through at least just one. Just go through the launching spot instances. And if you've never done auto scaling, then maybe do auto scaling, right? There's also another one like EC2 workloads at scale, CI/CD, some model training. Carpenter, by the way, is an open source tool that AWS released to help manage Kubernetes clusters. It's a fun little tool, but there is also some stuff for ECS and EKS here if you've never touched those. But if you've never touched spot instances, I will highly encourage you to actually launch this private lab, run it yourself. As always, please delete the resources when you're done. I don't want any of you ringing up unnecessary bills, right? So just FYI. So those are the general licensing types available to EC2. There's dedicated, which isn't listed here, but we talked about it. On demand, and then there's reserved instances and savings plans, and then there's spot instances. Spot instances, by the way, can give you up to a 90% discount off of the on-demand price. So spot instances rock if you can use them. So just to rehash this, because I know we just talked about it, but I'm just going to give it to you with the slides, right? Is that remember that reserve instances can be up to 72% off the price. There are 2 flavors. There's actually 3 flavors, but I'm going to say 2. Standard reserve instances, there's convertible reserve instances, and these are for 24/7 workloads that are going to run 24 hours a day, 7 days a week. There's actually a third type called scheduled reserved instances. You can actually go to Amazon and say, look, at the first of every month, I want you to give me a discount on a box that I run for 24 hours. So there is also a third type called scheduled reserve instances, where you can say, I don't need it for a 24/7 workload. I just need it for the first of the month for the first week, or I need it for the last week of the month, or I need it Monday through Friday from 8 to 8. There's actually a third type. I don't know why they don't list it here, but it's very popular, but it's called scheduled reserve instances. Of the three reserved instance types, the convertible reserved instances are the ones that are a little bit more flexible about operating system versus family size and whatnot. But you're still locked in to a particular region, a particular availability zone, and typically the OS, it is harder to change. Notice that you don't get as deep of a discount with the convertible reserve instances as you do with the standards. Okay, so these are also known as reservations, but reserved instance types, these are the two. The third one, obviously, I mentioned scheduled RIs. That's another option. One little caveat, just like savings plans can apply to more than EC2 instances, I want you to just keep in the back of your mind that if you're looking for discounts off of things other than EC2, the concept of reservations or reserve, like reserving something, exists for DynamoDB, CloudWatch, Elasticache, tons of other services. So make sure you're talking to your AWS partner rep, whoever your liaison is, either internally or externally, if you want to know what the discounts are. There's also a great white paper called Pricing on AWS, if you need it. Now, we talked about savings plans as kind of being the other side of the coin, right? So savings plans are where you don't sign up for 1 to 3 years. You don't give your word that you're going to get into a contract with AWS. Here, you're actually going to give AWS money, right? And they'll give you up to a 72% or a 66% discount off of things like compute or off of the particular EC2 instance. And remember, I did say they have savings plans for SageMaker. So for those of you who are starting to deal with machine learning capacity, there is a savings plan for a SageMaker as well. So keep that in your back pocket. And notice that the comparisons here, this is something you probably want to spend some time kind of looking at, is that notice the discount levels, right? The standard RI and the savings plans are going to give you up to 72% discount. But if you decide to include Lambda and ECS and EKS in that, and you want to do a compute savings plan, you're going to get up to a 66% discount if you do a 3-year term, depending on what level of money you give them. And then notice you can get a lot of flexibility with convertible RIs, but, right, your discount's going to be way lower. Okay. So worth like spending some extra time. Just remember in your student handbook, you probably want to just take a little bit of time just to make sure you understand how these function. Notice here that it automatically applies to Fargate and Lambda functions. So the compute savings plan is the one that applies to all compute, not just EC2. And last but not least, we're just going to rehash Spot for a second. So when you go and make a Spot request, you're going to say, this is the maximum price I'm going to pay for this instance, the desired number of instances. You're going to like put a launch template on there and like, do you want this to go all the time, or you just want this to be a one-off? Is this ad hoc, right? And then the date range that this request is valid from, right? So just know that you will never pay more than on-demand price for your Spot instances. But as I mentioned before, you're going to get a 2-minute warning when someone else wants that box. So like, think about that. If you do it at 3 o'clock in the morning on a Saturday, you are very unlikely to be interrupted. If you win a Spot instance at 3 o'clock in the afternoon on a Tuesday, you're very likely to be interrupted. So just think about when you're placing your bid, right? Because that's also important. Like if you're running batch processing, do it at 3 o'clock in the morning on a Saturday and a Sunday, because nobody's doing anything except other people who are running batch processing. And do it in a region where hardly anybody's in, you know? Like, don't use US East 1. Everybody's in Virginia, right? Everybody's in Oregon, right? Don't go to Northern California because that's more expensive. Go to Ohio, right? Go to Toronto. Go down to Sao Paulo. Go to Brazil, for that matter, right? Don't do it in common regions where everybody's hanging out, right? Everybody loves US East 1 and US West 2. Go somewhere else to run your spot instances, okay? Especially if you're doing batch process. Ideal workloads would be like big data, genomic, oil and gas, any kind of geographic, crunching, anything stateless, like web services that are stateless where the backend is actually somewhere else. Test runs where you have long test cycles, like as part of CI/CD. Like these are great for Spot. And more, there's like lots of great tooling to enable Spot to work for you. So don't give up on it because you're like, my application can't withstand interruptions. That may be true, but there might be other use cases where it might work. Notice that a lot of these like fleet tools, by the way, will allow you to combine these licensing types where on demand could be your fallback on top of a set of reserved instances, and Spot could fill in overflow if Spot's available. So just know that like they have this thing called EC2 Fleet, and Fleet allows you to create these mixed licensing type, these fleets of EC2 instances. That's a little bit more in the professional level of class and certification, but just know that it's an option. It's out there to allow you to create these mixed, like huge fleets of systems that are your like web servers or your application servers. Typically, by the way, people don't do this for database servers. So you're either going to use a managed service for that, or if you're using like Elasticsearch or Cassandra or something on EC2, you're probably just going to buy reservations at that point in time. So FYI. Good. Any questions about these four, actually 5 licensing types for EC2? Okay. Don't worry, I'll ask you some questions later that are going to test your knowledge of that. After we finish the lab, I'll ask you some questions. Okay. What about storage? You can't really launch a virtual machine without a disk underneath it, right? Well, the answer to that is EBS. So EBS, the Elastic Block Store, which I don't know why they don't spell that out, but it's Elastic Block Store. These are virtual hard drives that are purpose built for EC2, not for anybody else, just for EC2. So the life cycle is that you create one, and just like a USB drive, you attach it to a virtual machine. You use it. You can snapshot it or back it up if you want to, and then you detach it, and then you can destroy it, right? There are 4 different family types of hard drives. They are used for very specific things, but all of them max out at 16 terabytes of volume. Just want to make sure I'm clear on that. They max out at 16 terabytes of volume. And there's 2 general classes of the family here. So like you're like, but Michael, you just said there were 4 members of the family. Yes, I did. So there's the SSD backed, and then there's the mechanical backed hard drives. Now, ignore the fact that there's a GP2 and there's an IO1, because I got to tell you, you're not going to use that. You're not going to use the older versions of the hard drives. I don't know why they list them here. You want to use the newer versions of the stuff if you can. It's cheaper and faster than the previous generation. So here, by the way, you've got GP3, which is general purpose generation 3, and then you've got IOPS intensive version 2, and you've also got kind of what they call ST1, which is really just like throughput optimized. That's what the T stands for, is throughput. And then you've got SC1, which is cold. These particular systems right here in red, first of all, these cannot be boot drives, so you can't use them to put your operating system on, and they are really only used for like colder, more archival storage. Now, some people will use ST1 because it has better sequential throughput for like streaming and stuff like that. But you're going to run into weird random use cases where GP3 and IO2 are going to be better use cases. And just so you know, there is actually a version of IO2 called IO2 Block Express. That's the one. Oh, look, there it is. Actually says that in the slides now. That must be a new addition. It actually says Block Express is the one that will get you to 256,000 IO per second at a 256K chunk size. So that's really fast. Most use cases, by the way, are going to use what's called GP3. You're going to use general purpose 3. That's going to be your boot drive for your operating system. That's where all your files are going to be. And by the way, you can attach multiple EBS hard drives to a single box. The only real limit there is the operating system. Usually it stops at around 16. Sometimes you can get more, right? But GP3 is pretty much your best friend. IO2 is used for intensive throughput databases. That's really what IO2 is for. And the other ones, ST1 and SC1, are just really just archival storage. Amazon will say that ST1 can be used for sequential workloads. No, try to stick with GP3 if you're going to do that. Just trust me. So those are the general types: GP3, IO2, ST1, SC1. They will ask you questions like that you can find like on this slide here. What's the max, general purpose SSD? Notice, by the way, that Block Express on the right-hand side doesn't cap out at 16 terabytes as a maximum volume size. It caps out at 64 terabytes. Notice these numbers down here as far as IO and maximum throughput for volume. So GP2 actually can burst up to 16,000. GP3 will just go to 16,000. Right, and IO1 and IO2, you can actually turn the dial on how fast you want the IO to be, but it can go up to 64,000 IOPS on those systems. So notice though that your throughput per volume is still capped at the number that's pretty much listed below, regardless of the IO number. So you're going to get about a gigabit per second off of the IO series. You're going to get about 4 gigabits, Gibby, right? Gibby bits per on the Block Express system. Okay, so quick test. What did I say was the one that most people use for most use cases? Which one did I say was the most commonly used one?
GP3.
GP3, right? You could technically probably say like GP2, GP3, but I'm just going to recommend that you use GP3 as much as possible. It's the latest generation, cheaper, faster, right? Good. Good. Hard drives, by the way, in some cases are, in all cases are auto expandable and can be contracted on the fly. You do have to be careful about the file system. So remember, take the operating system into account if you decide to shrink or expand the file system. Most of the time you can do that, by the way, with almost no interruptions. It causes no issues. I actually did it live on a Cloud9 box the other day, and the students were like, "Did you just expand the hard drive?" I was like, "Yep." It's like, it didn't reboot. I was like, "No, it didn't need to." Right? So just keep that in mind, is that you can auto expand and contract the drives as needed. For the throughput optimized, just something to keep in mind is that you're only going to get about 500 megabytes per second off of that system, and that's if it's sequential. So random IO is going to kill that drive. Again, as a general rule of thumb, don't use ST1 and SC1 for anything other than archival purposes. Notice that they also still both cap out at 16 terabytes. So okay, now we're out of the realm of permanent storage, like persistent storage. So we're not talking about EBS anymore. Remember, I mentioned that some of these systems, so if we go out to ec2 instances.info, some of these systems actually come with their own instance storage. So see this section called instance storage right here? This is NVMe SSD backed storage. It is super fast and it's super temporary. In some cases, you can actually boot the system off this drive, but here's the problem. general rule of thumb is do not use this for any data that you cannot stand losing, because if that system crashes, that data is gone. If that system accidentally reboots, that data, no, not rebooting, that system accidentally stops, that data is gone. So as a general rule of thumb, we don't use instant storage. We only use EBS for our systems. It just saves so many headaches. Do note that if you use instant storage, you cannot stop that instance. You can only reboot it. So you can't migrate it also to a new piece of hardware. So you got to be careful. Because that NVMe RAM is local to the host that the virtual machine is using. If it loses its relationship with the host because it's got to go to another host because that host failed, you're going to lose that storage. Bottom line, don't use instant storage. Know that it's there. Know that Amazon's going to ask you questions about it. In general, you don't want to lose it. You don't want to use it unless you're willing to lose it. That sounds like a really bad car salesman phrase. You don't want to use it unless you're okay with losing it. Bottom line, don't use instant storage. I will point out though that it is super fast. So if you're looking for a place to scratch out some temp tables or do something ridiculous that requires a lot of intensive IO, it can be fun, but not in production, as a general rule of thumb. I also want to point out that you cannot, if you stop an instance that has an instance store attached as like a D drive or, you know, like a /data or whatever, that data is gone. So it doesn't matter what role the instance storage plays, whether it's the root volume or if it's one of the other drive letters, it's gone. Okay, so don't use it. Any questions about any of this? No, you guys are all just taking it in. Good. Okay. All right, let's talk about high performance computing and then Lambda, and then we'll crack over to a lab for your last hour before we go to lunch, actually. Okay. All right, high performance computing. First of all, anything where you basically need incredibly compute intensive workloads. So any batch processing, you know, this isn't necessarily EMR or Spark or any of the kind of like scalable distributed computational systems. This is just straight up like raw arithmetic, right? Genomic data, obviously any kind of simulations, insurance, you know, number crunching, that kind of thing. I imagine high frequency trading probably falls in there somewhere in my imagination. So note that there's a bunch of options to kind of make this kind of thing work. The main like items that are of interest to people who are, you know, wanting to know how to maximize HPC is typically going to be parallel cluster, placements groups, and then these networking options. Auto scaling is always an option if you want to like have systems elastically respond and whatnot. And then of course, batch processing is always available to you at scale with batch. The rest of these are all just nice little add-ons for storage, of which I would argue that Lustre is probably the one that people look at the most when it comes to HPC. So just know that there's a couple of different things. The parallel cluster, by the way, is a framework really for running clusters, HPC clusters on AWS. So it's not really like a kind of a full-blown service in and of itself. So you're gonna have to look at the framework and how it basically you use it to orchestrate clusters inside AWS. Now that being said, the networking options are ridiculous. So by default, everybody gets an ENI on their system. An ENI is just a network interface. That's all it is. If you go look at ec2instances.info where we were before, you'll notice that networking performance is listed over here. Right? You can see that, you know, you can get massive gigabit performance off these systems. You know, and these systems aren't even particularly large. If we were, for example, to grab like I'm trying to think of something. Let's go take a look at the C6s. Again, not super large, but there are 100 gigabit boxes down here. This is bare metal, obviously. Let's go take a look at the G series. Like the G4. So we got 100 gigabit boxes, 25 gigabit boxes, 50 gigabit boxes, right? On the backplane, just for raw network performance alone, which I gotta say, I mean, 10 gigabits, 25 gigabits, 50 gigabits, that's a lot of like compute and speed, right? If you need to go faster than that, an ENA will get you, is what's required to get you up to that 100 gigabit like setup. And it does use like pass through, which is known as SRIOV, which basically allows the virtual machine to talk directly to hardware, basically at that point in time. And if you need to go even faster than that, instead of an ENI or an ENA, a network adapter, you can actually get what's called an EFA, which is a fabric adapter, and that will get you up to 400 gigabits a second. This is only supported on certain instance types, just like the ENA is. So you gotta like do some research about what systems will work with that. And it's really for those systems to talk to each other. So you can't expect that you're gonna get 400 gigabit bandwidth out to the internet. That's not gonna happen. But as far as like, getting an HPC cluster that is able to optimize its traffic using scalable, reliable datagram, right? To actually like has the basis for its connection building. This is a great resource to look at, is using EFAs on your HPCs. So just know there's options. That's the main takeaway from this. Now, what if you want to make sure that virtual machines are placed close to each other? Well, if you don't, by default, if you don't specify any controls around how you want your stuff placed, Amazon's going to basically attempt to spread out all your instances across all the underlying hardware, right? So even this isn't accurate, really. Amazon would have placed you across all 4 boxes. So that's a little bit of a misnomer. You wouldn't have seen 4 of those stacked on. It would have actually tried to spread you across. Amazon tries to put you on boxes that you're not currently on. So it minimizes the loss of systems in case there's an outage, right? This is without any placement group definition. With placement groups, which is something you can specify when you launch a set of instances, you can actually place them in the same server rack or force them to be in separate server racks. It just depends on how you want to do it. So the cluster strategy says, I want you to place them as close together on the same host as much as possible. Now, why would you want that? Someone tell me why you would want all of your virtual machines on the same VMware host, as an example, or Zen hosts. Yeah, David, that's exactly right. 100%. Latency reduction. If you're not actually having to go across a network router or switch or whatever, that means you're all in software, which means that your speed is the speed of the software, which is typically in memory. You're good to go, right? It's going to be lightning fast. But that might not meet your business requirements. So you might need to force it to partition it out, to spread it out. And so like things like Hadoop, Cassandra, other kind of like Airflow, Aeroflux, other distributed databases, they might want you to force everything to be partitioned out and spread across systems. And then, you can actually make it so that within the same availability zone, everything's like put on the same box. You can make it spread so that everything is spread across availability zones. So nobody's on the same box and no one's in the same availability zone. And to make it weird, you can even force everybody into their own single availability zone, but force them to be on separate pieces of hardware. So you don't get the redundancy of multiple availability zones, but you're also not stacking everything on the same piece of hardware. I don't see people using partition placement groups a whole lot. I see people using spreads and I see people using clusters quite a bit. Clusters more, because if they're going to do spreads, by the way, they're typically using an auto scaling group, which is going to spread them out anyway. So neither here nor there. So there's the 3 types. Cluster, which means we're going to put everything on as tightly together as we can in the same availability zone. Spread, which is going to spread it across all the availability zones. And even within the availability zone, we're going to make sure boxes are not on the same piece of hardware. And then there's partition placement groups where you're in the same availability zone, but you're forcing sets of boxes on separate hardware. So that way they can withstand at least one host failure. Good. There's a quick summary of that. Questions? Anything there that's confusing or didn't make sense? Okay. All right, last but not least, Lambda. Probably a pretty easy conversation. So here's the deal with Lambda. It's basically you give Amazon your code, you answer a few questions, you set up permissions and triggers, like what's going to trigger this code function to run. And then Amazon will run it to whatever number of concurrent executions you're willing to pay for or support. So if you're like, look, I'll pay, this thing can run up to 1,000 concurrent executions. Cool. You could call up Amazon and say, look, I need this thing to run 10,000 concurrent executions a second. They'll support that, right? So some of that requires you to at least open a support ticket, because by default, they won't let you run super high numbers. Amazon, by the way, has these thing called service quotas that are in every single account. So you cannot actually hurt yourself horribly by accidentally spinning up 10,000 virtual machines. Like I found out the other day that Heroku runs about 200 to 300,000 virtual machines a day. That's a lot. And some of it's actually on AWS infrastructure. I was like, how did they get away with that? And it turns out that they, excuse me, have talked to Amazon and have their service quota limits raised up. By default, I think you're limited to like 1,900 virtual machines in a single region if memory serves correctly. So you do have to negotiate. You have to like open up some requests to really do something crazy. Horror stories of people like spinning up 10,000 instances or whatever. Those are probably just stories, honestly, because Amazon doesn't let you do things like that out of the gate. You'd have to be a big established enterprise company that they have a relationship with. So serverless computing is where you just give the code. The code is invoked based on some kind of event trigger, which could be time or it could be an event. And that code executes and it can access whatever you've given it permissions to execute. So if you want it to talk to DynamoDB, you want to talk it to SQS, the simple queue service, or you want to talk it to notification service, it can do that. Now, it says supports up to 10 gigabytes of memory. I want to say that recently went to 30, actually. I think that was just recently changed to 30 gigabytes of memory. But it will only run for 15 minutes. So this is where things get weird. This is not for a 24/7 running application. This is for a function that can run within 15 minutes. So this is not for data processing. They have a thing called Glue for that, which is basically just PySpark. That can run indefinitely, right? This is only for one-off functions that are supposed to execute a chunk of a user's workflow within a 15-minute period. So this is not really like where you're going to run a web server 24/7. This is not for that. This is for event-driven architecture. When I say event-driven, here are a bunch of the sources. So S3 buckets could be used to run this, to trigger the Lambda function. And I'll give you a real-world example. I didn't know this was the thing, but back in 2014, I was the director of DevOps for like a video company that ran ads on top of other people's videos. It wasn't a proud period of time, but I was learning what I liked and what I didn't like in the industry. What we did is that when people submitted their videos, their advertisements, they put them into our S3 bucket that triggered a Lambda function around the, this is like 2014, 2015. That Lambda function took that video, transcribed it, and then basically got an audio like version of it, like a audio version of it only, did transcription against it, and then converted it to a desktop format and a mobile format, and then published that onto another S3 bucket where it got picked up by CloudFront and served out all over the world. There were no servers in that process except for an SQL database, which was sitting off to the side. That was it. Everything else was Lambda. Lambda got triggered every time someone uploaded a file. It did a series of Lambda functions against that file, outputted it to another S3 bucket. No servers except for the database counter, which between that and DynamoDB, there was some metadata, right? That's it. So you could have S3 trigger it. You could have DynamoDB changes trigger it. You could push the button and trigger it. So you can manually trigger it if you want to. But just know that your trigger at this point could pretty much be anything inside of AWS because Lambda is really tightly integrated with the Lambda ecosystem. So this is great for everything from like chatbots to one-off IT automation to small batch data processing. Don't let that fool you because remember you get a 15-minute caveat. Some people have run like a simulated slot machine browser game. Some people use Lambda to front their API calls to backend services. So just know all you need to do is just submit your code into Lambda, and you have to follow a specified pattern with an event handler and some context, but it's really simple. And it can be Python, C#, Java. You can even do custom runtime. So if you're like using PHP, but they don't have a runtime for it, you can actually create your own custom runtime for Lambda. So this is functions as a service. I'm going to show you towards the end some great workshops to kind of like get into this a little bit more. But Lambda is a great service to understand how it's used because it will save you a lot of operational overhead, especially for those like one-offs, right? Thanks, Dave, for posting that out. I could have sworn there was a recent announcement where they were just upped it to 30, but thank you for pulling from the documentation. Anything involving numbers and my mouth and my memory is probably going to be a lie. So just thank you for verifying. So good. Maybe that was Fargate. Maybe Fargate went to 30 gigs. I can remember get those. There's so many changes, it's hard to get it confused. All right, so knowledge check. Okay, so what's true at this point in time? Which of the following are true of AMIs? A, B, C, D, or E? Okay, I see a lot of B's and D's. Oops, sorry. And that would be accurate, right? So AMIs can include the hard drives that are needed to define them, which is what a block device mapping is. So the EBS volumes, right? So it can say, hey, when you launch it, I need these volumes attached to it. That's an AMI can definitely specify that. And then you can actually easily kick off multiple instances from an AMI. AMIs do not have to only be obtained from the marketplace. So that C is false. AMIs can only be used by users within a single account. And that's absolutely not true either, right? AMIs can specify the subnets for launch. That's actually another like device inside of EC2. What is the name of that device where you can actually specify the subnets? Does anyone remember? I touched it briefly and I had a really simple one inside of my account. There we go, Rakesh. Yeah, launch templates, right? So launch templates can specify subnets and security groups and all the other stuff, but the basic building blocks are defined in the AMI. What operating system is it running? Does it have additional hard drives that need to be attached to it? Those are all specified in the AMI. Good. Okay, a little bit of the family types, right? In this instance type name, M6G 2x large, which aspect of the name indicates the instance family and helps to determine its best use case or the mechanical sympathy? Okay, so for 1,000,000 completely fake and worthless game points, what did I say M stood for? What does that stand for? In AWS's official
General purpose.
general purpose, right? So I said like M for median, right? To think of like general purpose, not M for memory, right? Now for another billion completely worthless game points, does anyone know what the G stands for? Which, by the way, you are not required to know. Does anyone know what the G stands for off the top of their heads?
Wasn't it like the processor or something?
That's exactly right. So here's the question I want to get to so you can answer it. If you look up EC2 instance types in Google, somewhere near the top, assuming there's no sponsored links, it should take you to the EC2 instance types documentation. If you're like, Michael, I need to know what that G is. First of all, you know that M stands for general purpose because we just admitted that. So you click on general purpose and then you're like, oh, there's the M6G. Click on that and you'd find out that the G probably stands for this Graviton processor, which is a proprietary ARM-based processor that Amazon built. Are your x86 binaries going to work out of the gate on this? No. So just know that those letters could be important to you. And this is how you look them up, is that you just, once you know what the M, the C's, the R's, and whatever, like if it was an R box, you'd go to memory optimized. If it said R6G, well, now you know that G stands for Gravitron, so that's an ARM processor. But you might say, I don't know what an R5B is, right? And in this particular case, I'm not really sure either, but it looks like an EBS optimized variant of the R5 instances, which means that it's built for heavy IO, right? It also, by the way, happens to have a Cascade Lake 8259 CL on it. So in other words, you go look at the documentation to see what's going on with it. Okay. Same for accelerated computing, same for storage optimized, same for compute, right? And remember, I said the T series is listed under general purpose. I probably would only use those for proof of concepts and for testing only. Be very careful using the T series in production. If you do not know how CPU credits work, you are not going to use the T series in production. If you understand how CPU bursts and credits work, then you can use the T series in production. Otherwise, please be very careful. Test it first before you launch the T series in production. Okay. So you got that right. Okay, so which of the following are true statements regarding Lambda? Take your best shot. Well, thank God somebody looked up the documentation. Special thanks for Dave for keeping us honest. Good. Okay. First of all, A is patently false. I said Python and PHP and Java and .NET and Go and yeah. So notice it says select two, right? Yeah, good point, Dave. So responsible for updating patching Lambda servers. That's the whole reason to use Lambda is you don't have to patch any servers. So that's patently false too. So A and B are off. C and D, well, we already know from my earlier faux pas that 10 gigs is actually the max right now for Lambda. And then I mentioned 15 minutes or 900 seconds before, so you knew that already. Functions require a security group. I mean, they require some kind of security, but they don't require a security group. They need a role, actually. So Lambda runs as a service. So you're going to assign a role, both an execution, what they call an execution or a run role to your Lambda function so that that Lambda function has permissions. But you don't do a security group. That's not necessary. So So the answer is C and D, just to make sure we're clear. Okay. So that's the end of module 4. Before we go forward, does anyone have any other questions about any of this? Oh, did I post that? Hold on. That was a good question, actually. I know I usually teach you how to find it, but I also like to post the links out there just in case. So I'm more interested in teaching you how to find it just because, you know, links can change and Amazon moves stuff around, but as long as you've seen it before. Okay. If there's no questions, then let's talk about lab 2. So lab 2 is build your Amazon VPC infrastructure. So we're gonna throw in a little networking here from before. And actually, let me just make sure. Yeah, we're good there. All right, so here's what's going to happen is that you are going to basically create a VPC. You're going to create a public and private subnets. You're going to create an internet gateway. You're going to create all the elements that we talked about in module 3 around networking. That includes, you know, the publics and the privates and the security groups and the NACLs. Well, the NACLs are going to be there, but you're going to create most of that already. Then you're going to create a couple of EC2 instances in the public subnet, and you're going to have like a NAT gateway, and you're creating EC2 in the private subnet. You're going to create all these items, and I think that actually the next page has it listed out. You're going to create all of these options, all these different pieces, and then you're going to test connectivity between the items, and then option task 1 and task 2 are optional, but they're going to have you test connectivity, and you're going to retrieve some instance metadata. Don't do what Michael Forrester did and put SSL inside of your loopback instances. Make sure you keep it clean and keep it at just pure HTTP and not HTTPS, okay? But those are your lab tasks. If we go look, if you open up the lab, and it looks like most of them are pre-warmed. That's interesting. A couple of you might have to wait a second or two for the lab to finish pre-warming, which that's a little weird. But this lab ostensibly takes, again, about 45 minutes to complete. They give you double the time. They give you an hour and a half to run down it. But you're just going to run through task 1 all the way down through task 10. And then there are the optional tasks down at the very bottom. Okay. But task 1 starts with creating a VPC in a region. Okay. When you start this lab, please be mindful of the region that it says it's in. So if all of a sudden your browser decides to switch out of US East 1 into Ohio, be careful with that. Make sure you're staying in the same region every time, okay? Otherwise, that's our goal. So go ahead and take a run at lab 2. I'll be here to answer questions. I'll check in with you at 1 o'clock. We're going to stop to take lunch. So if you finish early, please just give me the green checkbox to let me know that you finished the lab and you are free to go off to lunch. We're going to come back at 1 o'clock Central or 2 p.m. Eastern. And then we're going to open up, by the way, with some of the exam questions for EC2 so that we can test your knowledge over what you just saw. Okay. Otherwise, go forth and conquer, and you let me know if you have any questions.
I do have a question to begin with. My understanding is that the difference between running an instance in a public subnet and a private subnet is only how traffic gets routed to it from the outside world, basically from the internet. Is that an accurate statement?
Really, it's like whether, it's routing is obviously the key difference. So let me acknowledge that, Rakesh, you're dead on it. Routing is the key difference. I wouldn't say necessarily, though, that it's routing about how the internet gets into the instance. It's more about how routing goes out of the instance.
Okay. Because
just to say this, if you're in a private subnet running a NAT gateway, nobody from the internet can get to you.
Right.
NAT gateways will not reverse proxy traffic. They are only outbound. So I would probably say it's more about coming from the perspective of who's on the network going out, but routing is the only distinction. So you're 100% right there. Does it have a route to the internet gateway or to a NAT gateway? Right. Either way, if it doesn't have direct access to the internet, it's a private subnet. If it has a direct route, then it's a public subnet. That's it.
Okay. Cool.
Yeah. And all the firewalls and all the other stuff in between, they're at play regardless. So the routing is the only difference. Let's do a quick little challenge, right? Do a little study here. So this is from the EC2 section of the practice exams. So here you've got a company that has a cloud architecture that's composed of Linux and Windows. So they got a mixed environment of EC2 instances, and they're processing financial data 24/7, right? To ensure HA of the systems, the SA needs to create a solution that allows them to monitor the memory and the disk utilization metrics of all the instances. Now, this is something that gets covered in the CloudWatch section when we get to monitoring, but I'm just kind of curious, does anyone know the answer to this, A, B, C, or D? I'll give you a hint.
If I have to guess, I would guess maybe B.
I'm thinking it's D.
Okay, Mr. Fava, why do you think it's D?
Previous experience, not something I built, but from the forensic standpoint, and kind of needing to know where I could go to get log data, and CloudWatch came up, and I just remember the console more than the dashboard.
Okay. First of all, let's check and see if that's the right answer. So here's the thing that throws everybody off is that by default, Amazon is going to monitor everything the hypervisor can see. So the hypervisor for the virtual machine can see like processor, it can see allocated disk, it can see network bandwidth. Excuse me. It can see a bunch of metrics. But Amazon does not go into your operating system unless you turn on the agents and give it permissions to do so. So by default, you cannot see memory or disk utilization because that's an operating system perspective, right? That's from the operating system. How much of the 4 gigs that I was given by the hypervisor, how much of that am I using? Right, disk is the same way. I was given a 16 terabyte disk. From the operating system perspective, how much of that disk am I using? So D is the right answer, mainly because CloudWatch is where all metrics happen. But the other piece is that most people don't know that by default, it doesn't gather disk and memory utilization. So those are custom metrics that are omitted from the agent once you turn it on. And it could actually be the CloudWatch agent. It could be the SSM agent actually, because it also gathers metrics, right? But in this particular case, excuse me, you have to, the CloudWatch agent will by default gather the disk and memory utilization, and then they will show up as custom metrics. So technically that's correct. A is wrong because enhanced monitoring is not even an option, if I remember correctly, for EC2. You have to turn on detailed monitoring, which makes it more frequent. And then the default CloudWatch configuration to EC2 instances using Systems Manager agent, that's not correct, actually. You need to configure Systems Manager if you're going to use that. And then Inspector is a vulnerability assessment tool. So that's for like vulnerability assessment. It basically, looks at the network and the operating system, for known CVEs and reports those into inspector or into the security hub if you're doing aggregation. So C is not the right answer either. So, but you do have to remember that by default, AWS cannot see your disk and memory utilization. And they are going to ask you questions on that. They love asking questions on that. I don't know why that's such a fun distinction, but it's something they zero in on. Yeah, enhanced monitoring is a feature of RDS. I knew that. There's a vulnerability assessment. CloudWatch does not automatically provide disk and utilization metrics. Yeah. So that would not be a default CloudWatch configuration. Okay. We got 8 of these, by the way. Let's go to the next one. An org needs to provision a new EC2 instance with persistent block storage volume to migrate data from its on-premise network to AWS. The required maximum performance for the storage volume is 64,000 IO per second. So these are numbers, by the way, that don't change. So they will ask you to know which of the volume types supports 64,000 IOPS. So as you look at the answers, what are we going to use? There's a little gotcha there. Okay. Okay. That's where I see a couple of C's, right? So here's the catch. And this is something, this is a little bit of a marketing thing. In order for you to get to 64,000 IO, you actually have to use this system called Nitro. Now, Amazon has this Nitro system, which is this like combination of hardware and their like purpose-built hypervisor to basically reimagine like the whole like hardware to virtualization translation layer, right? So you've got to know that you've got to use the Nitro system if you want to actually get to the performance that we're talking about, to 64,000, right? And that's just something you just have to straight up memorize. If you're going to go above 16,000 IOPS, you're going to have to use, I can't remember what the letter is. I want to say it's N, but I don't think that's right. I don't remember what the, I thought it was either D or N, but I can't remember now whether this has, actually it does have Nitro. So maybe that is N. And that has Nitro as well. Let's take a look at another one. Does that have Nitro? Yep. So maybe N is the Nitro system. So let's take another N. So you have to, yeah, I guess N is Nitro. So you have to use N, the Nitro system, right, in order to like get it to that level of bandwidth. So once you get above 16,000 IO, you have to use the Nitro system for it to work. I believe that's also true when you go, excuse me, above 10 gigabits as well. So if you go above 10 gigabits in network bandwidth, I think you actually have to use the Nitro system as well, if memory serves. But again, remember memory. So here's the Nitro documentation. So technically the answer is C. So that's just something that, like you just have to know off the top of your head. I don't know that we even talk about the Nitro system in the slides. So Nitro right there. So latest generation of EC2 instances. Let's see, where is Nitro declared anywhere? Yeah. As far as directly attaching multiple instance store volumes to an EC2 instance, just to say this, an instant storage volume actually delivers about 180,000 IO per second, like random, which is like super fast. Especially the NVMe drives, they do that. But what's the problem with using ephemeral storage? How come we can't use instant storage here? What's the problem?
Not
Disappears.
Yeah. They said persistent up here, right? So it's ephemeral. You can't use it. Bear with me 1 second. My son's school is calling me. I'm just going to make sure he's still alive. Interesting. You know what? Pardon me for just 1 second. I just need to call and make sure that everything's cool with my son. I apologize since I know we just got back from lunch. Can we just take like a few minutes break? So it's 2:13 right now. I just need to call him back and make sure everything's cool. So let's take a 5-minute break. Come back at 2:18. I'll be right back. Sorry.
The nitro kind of makes me want a nitro cold brew from Starbucks right now. I don't know if you guys are fans of that.
Those are pretty great.
Makes me think of Fast and Furious. Just
I
going
think it's probably what they're going.
race car style.
And see, I think of those every time I see the NOS energy drinks.
They're making a 10th Fast and Furious.
Why?
It's the only thing Vin Diesel can make, I think.
I definitely hope it takes place in space, like the entire movie, not just a portion.
Didn't they go in space a little bit in the 9th one? Did you see that?
Yeah, they took a Fiero in space. It was great. Not really.
I just saw The Northman last night, the Viking movie that's out. It was really, really good.
Oh yeah, I liked it too. I saw it over the weekend.
It's intense.
Nice. Yeah, I saw that. Yeah, if you're into like the Norse mythology stuff, it's a really good one.
But
Yeah.
did that movie have a 2-minute quarter-mile race in 10-second cars?
No.
Yeah, then it's garbage.
It's giving me big God of War vibes, though. It's awesome.
Yeah, I've been watching The Last Kingdom on Netflix too, so that's been pretty awesome.
I haven't seen that. Check it out.
Yeah, it's really good. I wasn't expecting much of it, and now I'm like 3 seasons in 2 weeks.
Nice.
Yeah. You're up my alley, Alex. Love that stuff. That and Vikings.
Yeah, Vikings was great.
They're kind of like similar shows. Did anyone see the trailers for Kenobi?
No, I'll have to look it up.
Yeah, it comes out at the end of the month.
Did anybody watch the Avatar 2 trailer?
What? There's an Avatar 2 trailer?
Yeah.
I had pretty much written those off as Half-Life 3. They were talking about them, but never going to see them.
Is it like the same like film style and everything as like the first one?
It's hard to tell. You have to watch it yourself.
VR before it was cool. Yeah, I have to check that out.
Avatar 2 trailer and Kenobi. It's going to distract from my AWS learning.
They played the Avatar 2 trailer when I went to watch Doctor Strange, and it was a complete surprise. I wasn't expecting it at all. It was pretty cool. Anyone watch the Doctor Strange movie?
No, not yet.
No, yeah, I want to though.
It's got mixed reviews, but I loved it.
Yeah, the other one was okay. I mean, he's just kind of like a weird character, so it's, I don't know, I feel like some people like it or some don't.
Okay. Thank you for your indulgence. That turned out to be a non-event, actually. So my 14-year-old collided with another kid. Everybody's fine. So we're all good. Okay. So back where we were before before I got a phone call from the school. Okay, so I think we pretty much cleared up the IOPS thing. So again, 16,000 IO when you get past GP3, like that's GP3's top threshold, you're going to need to throw nitro on there in order for it to function. Okay. Next. Okay, so question number 3. We've got a company that plans to host a web application and auto scaling group of Amazon EC2 instances. The application is going to be used globally by users to upload and store several file types. So based on trends, files that are older than 2 years old must be stored in a different storage class. And the solutions architect of the company needs to create a cost-effective and scalable solution to store the old files.
Michael,
Yet still provide. Yes.
I think I'm stuck still on the previous screen.
Oh, thank you.
Okay, thank you.
There we go. I pause for some reason. Okay, there we go. So the SA is going to need to create a cost-effective and scalable solutions to handle like moving these files that are older than 2 years to a different storage class. Now, I got to tell you, I find this a little funny that it's actually underneath EC2, because doesn't that sound like a storage question? But regardless, we'll roll with it because it sounds like an S3 question. But if you were going to create a policy to move files that were older than 2 years to a lower tier of storage, the minute we talk about tiers of storage, we're only talking about 2 possible services, right? Maybe 3 if you throw EBS in there. So then what services, you got to select 2 here, are we going to use in order to solve the problem of 2-year-old files and then being able to upload and store several different file types across a auto-scaled group of EC2 instances? Okay. So I saw that B seemed a popular answer, right? So let's use S3 to store some files and then create a lifecycle policy that says, once the files are older than 2 years, let's move them to Glacier. So that makes sense, right? So remember that our requirements is that it must be cost-effective, scalable, and yet also provide durability and high availability. So what other options? So I see that E is the other option. Use S3 and create a lifecycle policy that will move the objects to S3 standard IA after 2 years. That also seems like a strong possibility, because to mention this, it doesn't actually say anything about when it goes to the other storage class, does it need to be available or unavailable? All it says is it's going to store the old files. So out of these options, one thing that we can do right off the bat is that we know that EBS is the most expensive way to store files. It's the fastest, but it's the most expensive way. Plus, it won't scale across an auto-scaling group. So we can go ahead and take C and D off the table. Now that leaves A, C, B, and E as the possible options. B definitely works. E definitely works. And EFS could also possibly work. And EFS does actually have, I know this is surprising, but different classes of storage. By the way, so does DynamoDB. Most people don't know that DynamoDB also has infrequent access tables, right? Most people don't know that. But just to say this, EFS is more expensive than S3. So if I were to just go with a guess, I would agree with David and be like, you know what? B and E seem like the most likely answers. Let's see if we're right. In this case, we are, right? So let's take a look and see if there's anything in here, right? First of all, here's the standard storage classes, which we're going to cover once we get to storage here right after this module. And let's see. EFS doesn't work. Oh, that's right. I forgot about that. The maximum number of days for EFS's lifecycle policy is 90. Yeah, that makes sense. And then EBS volumes, because EBS costs more. And then, you know, once again, EBS costs more. I don't know why it didn't say it down there, but it should. So EBS is not going to be the answer. EBS is the answer if cost isn't an issue and you want the most performant disk. EBS is going to be your friend.
Will there ever be situations where they have us configuring RAID for AWS storage?
There have been questions in the past where they'll ask you to configure RAID, and usually it'll be like RAID 5 or RAID 10. I don't remember exactly like what the scenarios of those questions were, but most of them have been phased out of the exam. The only place that I think they still exist is on the SysOps exam. And they'll ask you to do RAID 10 when you need a volume larger than 16 terabytes, right? They'll do some kind of like variation on that and say, hey, we're going to do RAID 5 for this because I need a volume larger than 16 terabytes, but I need to be able to withstand the loss of one disk. RAID 5 like would be the thing you would look at. They don't do weird RAID like odd ones like 6 or 7. They don't do any of the kind of proprietary RAIDs, but 10 and 5 are the only ones that they give scenarios for.
Oh, okay. Good to know.
Yeah. So a stripe with redundancy, you know, a duplicated stripe, right? Or like an array, or RAID, you know, a RAID array with parity, which is what RAID 5 is. Okay. Here are companies deploying an HPC cluster that spans multiple EC2 instances across multiple AZs, and it does wind simulation processing. The SA is experiencing a slowdown in the application, and upon further investigation, it's discovered that it's due to actually latency issues. The very thing that a lot of these placement groups are supposed to solve, right? What is the most suitable solution that the SA should implement to provide a low latency network performance necessary for these tightly coupled node-to-node communications for an HPC cluster? Good. You all seem pretty comfortable with that one. What's the maximum bandwidth on a direct connect connection? Rakesh, do you know?
I do not.
So oddly enough, it actually can go up to 100 gigabits, right? So, right. But if you need faster than that, like 400 gigabits, you're not going to get that unless you're intra host, right? So you're not wrong. There are use cases where direct connect could be used up to that 100 gigabit limit. But just know that that's mainly for network traversal. So it's not necessarily going to guarantee that the intra network stuff is actually fast enough. So.
Gotcha.
So the idea is that with a cluster placement group, let's put them all on one host. And then that way we're moving at the speed of memory for the most part. Oh, by the way, I'm assuming that's right. What if it's wrong? It would be great if I was like, yeah, that's the answer. That's totally it. And then we look at it and it's not right. That rarely happens. Okay. Company needs to deploy at least 2 EC2 instances to support the normal workloads of its applications, and it will automatically scale up to 6 to handle peak load, which is a very common scenario. The architecture must be highly available and fault tolerant, as it's processing a mission critical workload. So what should you do to meet the requirement of creating a highly available, fault tolerant set of instances that can scale down to 2 and up to 6? Remember, it has to be highly available and fault tolerant. So what is Amazon's best practice for that? Okay. So a lot of you put B. Let's see if that makes sense, right? So okay, so let's think about this. You've got an auto-scaling group of EC2 instances. You set the minimum capacity to 2, the maximum capacity to 6, and then use 2 availability zones to deploy 1 instance into each AZ. That makes sense to me, actually, right? You only need 2 minimum instances. You've got 1 in both availability zone. You've probably got a load balancer in front of it. So why not just run 2, right? Yeah. Right. Exactly. There you go, Connor. You picked up on it, right? But the thing here is that you need to make sure that there's a minimum of 2 instances instantly available in the event that, one of the others goes down, right? One of the other AZs goes down. So in other words, if you instantly lose an availability zone, all the traffic is going to be redirected to these 2 instances. Now you can wait to scale up an instance if the business is accepting of that, which is honestly probably what I would end up doing. And I probably would have still guessed wrong and put B in there as an answer. But technically the right answer is A, because that way, if you lose an availability zone, you never lose less than the 2 minimum instances to support normal workload of your application. Now, does that mean that those 4 boxes are going to be operating at lower utilization? Yeah, but the business needs to make sure that it never goes below 2, right? So in that particular case, the auto scaling group works perfectly, but in this particular group, you want to make sure there's 4 instances, 2 in one AZ and 2 in another AZ. Don't worry, I get this one wrong regularly myself because the reasoning, I always forget about the reasoning, right? But technically that is actually the right answer. It's 2, 2, that gives you the 4, and then that way you get the 2 minimum in case you lose one of the AZs. Does it feel more like a word problem than a technology problem? I agree. So just remember those little nuances. What are they explicitly asking for, right? What's going to happen if that AZ goes down? You're not going to wait for the system to boot. There's the reasoning. So, okay. Okay, a multinational corporation and investment bank is regularly processing steady workloads of accruals, loan interest, and other financial calculations every night from 10 p.m. to 3 a.m. And they're doing it in their on-premise data center, so not in cloud. Once the process is done, the results are then uploaded to an Oracle General Ledger, which means that the processing cannot be delayed or interrupted. So the CTO has decided to move their IT infrastructure to AWS to save money, and the company needs to reserve compute capacity in a specific AZ to properly run their workloads. What licensing type would you use to reserve compute capacity in a specific availability zone to properly run the workload? This is, by the way, where a scheduled RI. Remember the third reservation type that I talked about, where you can actually do it for either a chunk of time or a day of the week or week of the month. This is where a scheduled reserved instances actually would make sense, because you only need it every night from 10 to 3. So you could actually reserve what's called a scheduled reserve instance and just say, hey, Amazon, I don't need a 24/7 app. I just need to reserve it from 10 to 3 every night. Makes sense. So, most of you put B, so I'm going to go ahead and throw that out there, because I'm going to tell you right off the bat, this is a little confusing, right? This question, and I don't know if I talked about this yesterday. I hope I did. Some of these questions are really squishy and that you're not really sure like exactly what the answer is. And I know these systems pretty well, right? So use on-demand capacity reservations, which provide compute capacity that's available on a specific reoccurring schedule. This must be what they have either renamed or changed the scheduled RIs to, is that maybe they've changed it to some kind of like new name, like capacity reservations. So it looks like that's what's happened, is that there's now the name for scheduled RIs is now on-demand capacity reservations. So you can reserve capacity in a specific availability zone for any duration of time. So I learned something new today. I guess I somehow missed this in the announcements, is that now scheduled RIs are called on-demand capacity reservations. So interesting about this is that there's no commitment required, can be created and canceled as needed. You put capacity in a specific availability zone, no billing discount, so you get no savings, and your on-demand instant limits still apply. So what this means is that they're guaranteeing you that you're going to have access to the resource, but you don't get a billing discount. Well, that's very different than scheduled RIs. That's weird. Okay, good to know. So on-demand capacity reservations allow you to schedule capacity with no billing discount. I learned something new myself. So, wow. Just know, by the way, that if you go in and do a normal reserved instance, you get a capacity reservation and you get a billing discount. So, yeah, interesting. Maybe they've stopped doing scheduled RIs. Yeah. Remember, before you start flipping tables, remember that 15 out of these 65 questions are throwaway questions. This could be one of them, or it could just be that I just didn't know that on-demand capacity reservations were a thing. So, yeah. Okay. All right, on to the last two. This media company you're working for has a video transcoding application running on EC2. Each EC2 virtual machine polls a queue to find out which video should be transcoded, and then runs the transcoding process. If the process is interrupted, the video is going to be transcoded by another virtual machine based on the queuing system. So the application has a large backlog of videos which need to be transcoded. So your manager would like to reduce this backlog by adding more EC2 instances. However, these instances are only needed until the backlog is reduced. So in this scenario, which type of EC2 instance is probably the most cost-effective to use? So you're instantly answering the question is, first of all, can this process be interrupted? And the answer is, I think most of you have drawn the same conclusion, is it looks like this process could be interrupted. Now, just a word of warning, if there's a video out here that takes more than 15 minutes, that's not right, but takes keeps getting interrupted because it needs an hour to like transcode, make sure you've put processes like a dead letter queue in order to track and see why that video keeps getting hung up. But we're not running into Lambda limitations. We're running into limitations where we don't know if we actually have spot instances for a long enough time frame to do the transcoding. That possibility, that edge case notwithstanding, spot instances make total sense. This is a process that can withstand interruptions. So, why wouldn't we use spot instances? It is by far the most cost-effective way to run this process. So out of all of these, spot instances is always the most cost-effective. And of course, this was the key that threw us towards that. If it made no mention that the process could be interrupted, you'd probably end up having to use on demand, honestly. But since it said the process could be interrupted, then it's totally fine for us to use spot. Is that distinction clear to everybody? Because any question that comes up like this, if it says that the application can be interrupted, the answer is most likely spot. Okay. All right, let's do our last one. Hopefully this won't be a squishy question. All right, we're automating the creation of EC2 instances in your VPC. Hence, you wrote a Python script to trigger the Amazon EC2 API to request 50 EC2 instances in a single AZ. However, you notice that after 20 successful requests, subsequent requests fail. What do you think the problem is? This one's deep into the meta, by the way. So this is all about service quotas and service limits per region. Or per AZ in some cases. All right, I saw a D first, I saw an A and a B. Let's just throw this out there and see what's out there. So here's the deal, is that there's a virtual CPU based on like limit, especially for on demand per region. So I don't know what it is off the top of my head, but if all of a sudden I started seeing after 20 successful requests that fail, it's not going to be the API. The API would throw an error and say, 500 error, couldn't talk to the back end, right? Some variation thereof. What it's basically saying is like, I'm rejecting this request. It would probably tell you, by the way, why it's rejecting it. It'll say you hit your quota for the region. The API won't just fail. It'll say unable to provision an EC2 instance because you've hit your region quota limit. It'll be descriptive. It'll tell you. Not all the time, most of the time. So what will happen is that you can actually just go into your account, and in your account, there's a section called service quotas. And you can literally just go in here and by service, let's say EC2 in this case. You can go in here and see what the quota limits are for, whatever particular thing you're looking for. Now, where's the virtual CPU? Let's go take a look. There's spot instances. Route tables, attachments, elastic IP addresses, dynamic routes, customer gateways. Oh, I'm like going, let's try this virtual CPUs. Huh. I don't want to do this manually, but usually it comes up a little bit more clear. Let's see, dedicated hosts. Not looking for that page. It's like a manual run. Not dedicated here either. More dedicated limitations. No, it's got to be the last page. Wow. I don't know where it's at then. Should be under EC2. Let's go back and take a look. Huh. Now I'm at a loss. Maybe it's not here. Maybe you actually do have to do that through a support ticket. Weird. Huh. I guess maybe it's not here. That's weird. I thought it was. Maybe I'm misremembering. Typically, by the way, if you're running into service quota limits, you can actually just find them there. And usually in the service quota option, you just, change it to whatever you're looking for. Like I've come in here before with EC2 and actually changed the number of elastic IP addresses, changed the number of direct connects that I had, changed the elastic inference. Must be having a brain fart about where it actually is. Anyway, so this is where you typically make the request. And if you contact support, which you can always do, they'll redirect you to just say, hey, open a service quota ticket. You can see it in there. Like, here's like, for example, quota request history. Probably more likely in Northern Virginia. Wow. Where is all my stuff? Oh, this is all within the last 90 days. So it must have been older than that. So usually you can come in here and make the request you need. And so in this particular case, you can actually just submit the limit increase form. But I guess for whatever reason, I can't remember. But there, you can see the actual limits. They should all be listed there. For some reason, I can't find the instance limit per region, which I might have to look when you guys are on labs, see if I can dig it up. It usually, by the way, is a regional limit. It's not going to be an availability zone limit that you're looking for. So in terms of this question, you just have to remember that there's a bunch of limits in there. Do you need to memorize them all? No, but remember that they are per region limits. So as you switch to different regions, you're going to have the same enforced beginning limit, but as you shift them up, remember, if you go to another region, you're going to have to request the same quota increases if you decide to expand into another region that you did in your primary region. So for purposes of this question, just know that there are regional limits and that you either have to submit a ticket to support or you have to go into the service quota service to get that to function.
Michael, are you trying to say that there are no limits that are enforced at the AZ level?
No, there are some limits that are enforced at the AZ level, but most of the bigger ones, as far as anything related to any of the services, those are for the most part per region. They're not per AZ.
Gotcha.
Yeah. Things like, for example, number of subnets allowed per availability zone. Those are subnet specific structures. Even though you can run virtual machines at an availability zone level, the most of the limits for that are managed at a regional level. It's like S3 buckets. S3 buckets are live at a regional level. They're managed at a global level, right? So it works the same way. I don't think there's anything else to share there. Yeah, CPU is based on per region, not per availability zone. So, okay, last question. We will talk about service limits when we get into support, so we'll talk about those in a little bit more detail. Okay. I think that's it for the questions on EC2. Actually, it was a little bit of a mixed bag. It seemed like there was more adjunctive stuff around EC2 than there was EC2 questions themselves, but there were some questions. All right. So let's talk about storage as our next kind of journey. And then we'll talk about database services, and then we'll probably end with a lab today. That'll be the last thing we close with. Okay. I had a buddy of mine the other day who was super excited that he was using 8.6 petabytes of storage inside of AWS, running a medium-sized business just south of $150 million per annum. Just out of curiosity, do you guys have an idea of how much total storage you have? Most people don't. Most people don't know. Have no idea. Even the storage admins don't know, because you've got storage admins for production, other storage admins are doing file servers, right? And if you throw the corporate and the kind of production services things together, people just don't know. Okay. Storage is a pretty straightforward discussion because you're either attaching it to an operating system or you are using some kind of API call to talk to the storage system, like you're putting files on a remote storage system. So cool thing with block and file storage is that those are mounted inside of an operating system. And we've been using this storage type for like 20 or 30 years. Hard drives are block storage. USB drives even are block storage, albeit over USB, which is slower. And then file storage is our drive letter mounts, like That's our NAS, that's our CIFS, right? That's our SMB servers, that's Samba and all of its variants, right? That's us mounting using what's a network protocol to mount it as if it was a disk local, right? That's file storage. Now, object storage is relatively new. This is where Rook and Ceph and OpenStack Swift and EMC was the first one to come out with it. It was like Caldera or something like that way back when. They were the first to come up with this storage. And it basically, all it was an API call where you dumped a file on the wire. It got put in as an object. And basically it went into a database. That's what object storage basically is you dumping binary files into a database. If you want to pull the file out, by the way, you're going to pull the whole file out. If you want to update it, you're going to re-upload the entire file. Now they've gotten a little fancier, a little more modern now where you can actually do parts and pieces. But object storage, for the most part, you're going to put an object up there. It's going to have some metadata and some attributes and some actual data, an object ID, right? And that's how that works. Now, Amazon has at least one service for each of these. So let's talk about them. So what's our call to action? Well, first of all, storage is always at a premium in terms of like when you're running your own data centers, which I did for years up until 2016, and I swore I would never do it again. I would never run my own data centers ever again for any company ever. And I have kept true to that, right? But you're always running out of storage and you're trying to like dedupe and stack and falsify, it's like, you can never have enough disks though. People are just hungry for storage. So shared file systems then become essential because you want to be able to service all of your heterogeneous operating systems. And you need to offer a wide range of services. You got to have disks, you got to have network disks, and then you've got to have some object storage. Even SFTP is still in play, right? People are still using SFTP for batch style storage. So storage demands are only going to increase. So how do you transport data to or from AWS without using a network? In other words, is there a way for us to transfer a large amount of data using a portable hard drive or some other vehicle? We'll answer those questions. So how can you optimize storage costs and provide security while ensuring high availability? How can I reduce the cost of storage for like older data tiers? It's a big problem, right? Most of us have tons of data that we don't touch. I guarantee you if I got 10 people together and looked at their Google Drive, a full half of the files that are in their Google Drives, they haven't looked at in 5 years, easy, if they've had it for 10 years or more. And then what are some options to build scalable storage for like shared file systems for Linux? And then if I need to mass migrate data into AWS, how can I do that? These are the questions we're going to answer here with these next set of services. All right, so notice that EFS is on the back end over here on the right. That's important because, well, we got EFS over here. We got the folders. And then we've got S3. And S3 is object storage. And then do note also that we've got disks attached to the app servers. We've got disks attached to the RDS servers. We've got disks attached to the Memcache servers. Now, some of those disks you can't even see, but they're there. Okay, so storage services are straight up, right? The main thing you need to know is that their services are either about hosting storage, right? Proxying storage. So it's either hosting storage, there's either proxying storage, or there's data security and management. Those are the three major categories. You're either hosting storage directly, you have tools to manage and secure that storage, or you have proxies that act as gateways that you can like put in your data center so you can get to the storage. So you got storage proxies, we got actual storage hosting, and then we've got storage data and data security management, right? And I say proxies, by the way, and that includes like movement, like if people want to move data around, right? So just know we're going to touch at least a little bit, mainly on storage hosting. We're not really going to talk about data security management, and we're not really going to talk about data movement or proxying. Some mention of that, but mainly data hosting. So first, let's do object storage. So object storage is pretty straightforward. This is the one where you basically are putting objects inside of a database. That's not, I'm kind of simplifying things, but that's basically how it works. Is that you're sticking an object like a video file or a JPEG or whatever, you're sticking it into a database. The file, by the way, has to be 5 terabytes or less in terms of size. But other than that, S3 has no storage limits, meaning you can put as many 5 terabyte files as you're willing to pay for into S3. Now, this works. You just open up the console here really quick. You know, S3 is probably where most people like start. You know, so here are like all my like interesting and weird little buckets, right? Like here's the DevOps Cyber Club. Ooh, why do I have a 2021? Anyway, we'll come back to that. DevOps Cyber Club. Oh, look at all that encryption. Let's go back to 2021 and see if that actually has what I'm looking for. It does not. Does not have what I'm looking for. Well, let's look at my class then. My old introduction to Elasticsearch class. No objects here. Well, I'm just like knocking it out of the park today for my maybe Terraform. No, that was templates. Web Age Solutions. Let's go look at this bucket. Oh, here we go. So here's a like. Notice there's just a PDF file and a PNG in here. This bucket's not public, so nobody can get to it. But one thing to know about S3 is that since I put these objects into an S3 bucket, basically they are pretty much web enabled. They're just not available across the web because I have it all privatized. But this PDF, by the way, has a URL associated with it right here. If I open this bucket up and paste that link in the chat, you can all get to this PDF. Because this is actually storing things in a scalable serverless database. And these objects, the minute they're copied up here, automatically have a URL associated with them, but only if you let the firewalls, if you will, talk to the objects. Notice that this is hosted in US East 1. And I can do all kinds of stuff. I could turn on versioning for the bucket. I could set some replication. I can set the storage class to a lower tier of storage or a hotter tier if I want to. I can turn on encryption. I can turn on all kinds of metadata. I could lock it so that nobody can change it, but people can read it. That way for auditing and governance compliance. I could make sure that no one could ever change that file, not even me, the administrator. So S3 has all these ridiculous capabilities, but really what it is it's just a scalable file storage system. It's an object storage system. I have run entire video companies just off of S3, no other disks, just S3 hosting the video files. So this can host anything now, but it can't do any backend processing. So this is not going to host like server-side JavaScript as an example, but it'll host client-side JavaScript. It'll host a video file that you can load up in a browser. But there's no servers here, so it's not going to execute anything on the back end. All this is a file repository. That's it. Now, that being said, this is great storage for backup and restore, for image files, for web, for archiving and compliance, for logs. S3 is also great as a data lake if you want to set it up for that. When you create a bucket, it gets a name. So here's the bucket name. And then it gets this URL added to it. And then if you have a subfolder, also called a prefix, it goes here. And then here's the name of your object. Let's take a look at that in the management console. If we go back and look, let's take a look at this. Bucket name. right? Web8 Solutions is the name of the bucket. This URL S3 AmazonAWS.com is all just added to the end of the bucket name. Notice there's no prefix because I didn't put it inside of a folder. And then this whole thing right here, well, this and this is the name of the file. Notice that the plus signs, right, for all the spaces. So this is basically what this does, is it hosts objects. Now you can create all kinds of folders. They're not really folders, they're just prefixes. They look like folders because Amazon did that on purpose, so you would think it was a file system, but they're really just prefixes to objects. And access control can be done either through policies like identity-based policies, or you can use S3 bucket policies, which are resource-based policies. Now, ownership can also be public, where you allow people to publicly download and publicly upload files if you want to. Or you can control it so that specific users have access and other users don't, or a specific location has access, and a specific location doesn't. So you can do public, private, controlled access, and anything in between. Now, you may have heard people get busted all the time for sharing their S3, like social security numbers and whatnot, through S3. Amazon doesn't take any credit for that because they really go crazy to let you know that you have a bucket that is exposed to the internet. Let me give you an example. If we go look at my buckets, can any of you tell me whether any of these buckets are open to the public? And if so, what's the name? Which of my buckets are open to the public? Right. So just know, like if you sign up for Corey Quinn's Last Week in AWS newsletter, which I highly recommend, it's not only informative, it's entertaining as well. Know that it's going to tell you when your buckets are public, and that's going to be on you if you decide to stick objects in there that are of a sensitive nature. By the way, there are management tools like Macy, which will scan for sensitive information, sends you a notice. You can even make it automatically remediate the bucket so it's not public if it contains sensitive information. Just know that there are tools for that, AWS tools. Okay. Okay. So in addition to like firewalls for blocking public access, there's also, we can turn on versioning. What this does, by the way, is every time you change a file, it creates a complete copy of the file. If you delete the file, it creates a delete copy of the file. So by the way, if you want to delete a file that's got versioning turned on, you have to delete all of the versions of the file. So if there's 50 versions plus a delete version, you have 51 versions to delete. Okay. All right. Versioning is great, by the way, when you've got really sensitive information that you want a lot of people to have access to inside the company, but you are worried about collisions or people deleting things on accident. You could also turn on things like MFA delete, which requires a hardware key to delete something. You can also turn on object lock to make sure that people can read it, but they can't modify it. So now, cool thing about S3 is that S3 has hot and really cold storage classes. So by default, if you want to use S3 standard, which is the hottest like flavor of storage, along with intelligent tiering, this will give you milliseconds of access. So you get like 3,200 concurrent file accesses, if I remember correctly, for a single file with standard. With infrequent access, you still get the same speed, but if the file is accessed 100,000 times, you start paying a lot of money for that. So think of infrequent access as something that you use when the file is rarely accessed. This is for files that are rarely accessed that are easily recreatable. So notice that all of these provide milliseconds to access. So the file is still available, but this is the one that doesn't charge you for thousands of concurrent accesses. This one will, and this one will. Okay. The Glacier storage classes, of which there's two, there's Glacier and there's Glacier Deep Archive. If you put something in a Glacier storage class, it is not accessible directly. It has to be restored like a backup, and then you can access it. So if the word problem says, I want to store some files that don't have to be accessible for a year or more, Glacier is your friend. If it says, look, after 90 days, I want to store some files, but I still want them to be accessible, then you're going to have to use standard infrequent access. That's what the IA is, by the way. This is an infrequent access. This is infrequent access. So S3, standard and intelligent tiering are the hottest classes of storage. Standard IA and one zone IA are also still hot, but they charge you a retrieval fee if you start retrieving thousands per second. And then Glacier is archival storage. So it is not for active retrieval. It's for active storage. Intelligent tiering, I've kind of avoided talking about because it uses machine learning to identify your access patterns and then move the file to whatever version of storage is most appropriate. So with intelligent tiering, if a file hasn't been accessed for like 180 days, it goes straight into cold storage. If it hasn't been accessed in 30 days, it goes into infrequent access. If it's in infrequent access and all of a sudden it starts getting accessed, intelligent tiering will move it to standard. So think of intelligent tiering as a service where it will move your files to whatever tier of storage that you need based on access patterns. So intelligent tiering is pretty cool, but you do pay a small, very small premium to have that feature. So it can be worth it. It could save you money in the long run, but it might seem a little bit more expensive at first. Let's see. By the way, Glacier is encrypted by default. The rest of these do not encrypt by default. You have to turn on encryption in order for it to be encrypted. But know that Glacier is encrypted by default. It is the cheapest. So for example, if S3 standard costs you $23 a month for 1 terabyte of storage, Glacier Deep Archive costs you $1. So just know it gets cheaper, way cheaper, 1/24 the cost, 1/12 of the cost as you move into Glacier. Questions about any of this? Oh, it is worth mentioning that all of this is 11 nines of durability. That means it's going to take them like 100 years to lose one of your 10,000 files. I want you to be clear though, durability is not accessibility. Just means they're not going to lose your file. Doesn't mean you have access to it. I think they only provide like 4 or 5 nines of availability. So, you know. Glacier stores, you know, it doesn't use buckets. It uses these things called archives. Archives, I believe, are capped at 20 terabytes in size. So like you can have a single file that's 20 terabytes large. You store those in vaults. I know this is going to sound kind of strange, but Glacier can act like a virtual tape library. So if you have a virtual tape software and you want to hook it into Glacier or S3, they have this thing called the storage gateway. It's a virtual machine that acts like an iSCSI, like virtual tape library, and it fronts Glacier and it fronts S3. So it's kind of fun. Now, when you want to get something out of Glacier as compared to like standard or infrequent access, you have to move it from frozen to thawed, right? And you can do that by either bulk retrieving it, standard retrieving it, or expediting it, right? But here's the catch. if you want to bulk retrieve something, it'll take 5 to 12 hours to retrieve the set of files in question, and it's going to cost you nothing. If you do standard, it's going to take 3 to 5 hours for it to retrieve your data. And it's going to charge you 1 cent per gigabyte. Expedited charges 2 cents per gigabyte if memory serves. Again, this is me doing pricing off of memory, so consider that suspect, but I'm pretty sure that's right. Let's go take a look. Oh, I'm sorry, it's 3 cents. This is why we look. So notice it's 1 cent per gigabyte for standard. It's now 3 cents per gigabyte for expedited. That's a lot more, actually. That's in Ohio. I don't think it changes a whole lot. Wait, what's look at it, Northern California. They just had to add 10%, didn't they? Weird. The rest of it all looks the same. Okay. So remember, Glacier is frozen, so you got to thaw it out. And so bulk is free. Standard is 1 cent per gigabyte. Expedited is 3 cents per gigabyte. Now, with both Glacier and with S3, like standard and infrequent access, all the tiers of S3 storage, you can define lifecycle policies that says, hey, if it's older than 30 days, I want you to move from standard to infrequent access. If it's older than a year, I want you to move from infrequent access over to deep archive. So it's like a waterfall model for transitioning between storage classes. So, if you know that your data is like most of the cat videos that we ran back in 2014, 2015, the cat videos were good for about 30 days and then they were dead. They were completely dead. And we didn't need to keep the cat videos, but we kept them on in the frequent access because we like the SEO linkage and everything. After a year though, those videos were completely worthless. So they didn't go over to Glacier. We deleted them automatically using lifecycle rules after a year. Okay. I think I mentioned this before, is that you can turn on encryption at rest, so there's no issue there. So you can actually have 3 types of encryption. You can do customer managed keys. This is all server side, by the way. You can do server side where S3 manages the keys, and you can do server side where this other service called KMS manages the keys. Which one do you use? Well, if you want to control the keys, you're going to do customer managed keys. If you want to have FIPS 140-2 compliant key storage, you're going to have to use KMS. Otherwise, you're probably just going to use the standard SSE S3 storage, right? That's it. By the way, all of this is AES 256 encrypted. So Amazon doesn't use any other algorithm, at least not yet. And they have for like 10 years. It's the same algorithm. Bear with me. There we go. You can also, by the way, replicate objects. So like if you want to, create multiple like copies of your data stored in any Amazon S3 storage class is stored by default in 3 availability zones. So regional availability zones that are inside the region. They are separated by miles within a region. That might not be enough for a lot of DR compliances. So a lot of customers are going to choose to store their data replicated. So you can actually do what's called cross-region replication, where someone writes into a bucket in Virginia and it automatically gets replicated out to Oregon, as an example, or Ohio. So just know that you can do that. And then we've talked about this before. Another feature of S3 is that S3 can trigger Lambda events. And we talked about how, there was a video company where people would upload their videos, like advertising videos. Later on, they were cat videos. I don't know. I can't even explain that phenomenon. Anyway, advertising videos get copied up to S3. That triggers a Lambda transcoding function, which then writes to another S3 bucket. So S3 can, that could be because they uploaded a file. It could be because they changed a file. It could be because they deleted a file. You can set whatever trigger notification you want on S3 against Lambda. And then the last few kind of features that S3 has is that you can't actually speed transfer into S3 using what's called transfer acceleration. This is a really interesting feature because what this does is that if you're trying to upload a file into somebody else's S3 bucket, DNS intercepts the request, sends it to a CloudFront server, one of the edge servers. It takes the request and then runs it over Amazon's high-speed backbone. So instead of running across the internet, it actually uses the CloudFront/edge servers to speed up the transfer into S3. So that's transfer acceleration. By the way, they also used to have S3 for BitTorrent, which I didn't even know that existed until I saw the retirement announcement. They actually still have SFTP for S3. So you can literally create an SFTP server that dumps into your S3 buckets. Yeah, I know, there's a lot. And then you can also do multi-part upload. So let's say you got a 5 terabyte file. You want to split it into 4 or 5 different parallel pieces because that will maximize your bandwidth. Then you can do a multi-part upload. Most of that's done on the command line. It's not done on the console. So, by the way, once all the pieces arrive at the bucket assembles the file together. So just know that it doesn't need to get everything at the same time. It'll wait until it gets the last piece before it puts the whole file together. And you can pause it. You can delete the parts if you want to. So just know that that's all standard. And the last few things is that S3 also has features like access points, which allows you to basically create aliases to buckets. This also allows you to create security aliases. So this can be useful if you want different access for different people with different URLs. So you can actually create fake URLs that actually point towards your bucket. That's a access point solution. You can also add your own code so that when you go to retrieve something from a bucket, for example, as an example, it would scrub all the social security numbers out of the file. Isn't that a cool little security feature? You could get it so that someone retrieves the file from the S3 bucket, it scrubs all the credit card information and de-anonymizes all the data. You can redact information, you could resize images, you could filter rows. This is all done through lambdas that get activated when you go to pull a file or change it in some way. So it's actually pretty robust. It's a pretty cool feature. And then kind of the last few pieces is that S3, let's actually go to the simple monthly calculator because I think this would make a lot of sense. And actually, we're going to go to the new calculator. Calculator.aws. Let's create an estimate. Let's do S3. Let's configure the simple storage service. All right, so first of all, let's switch over to West Virginia. Yeah. So we're using standard, but let's say we also want to use deep archive, and let's say infrequent access. So notice that, I did this before, I think you saw pricing, but let's say I'm going to do 1 terabyte per month of storage. They're also going to charge you for any API read calls that you make. So let's say we do 10,000 read calls a month. Let's say other than puts, copies, posts, or lists, let's say I'm going to get or select certain subsets of data, let's say 100,000. I'm not going to use S3 selects. That's a kind of an inventory run. What's that going to cost me? Well, it's $23.44 for the terabyte of storage, and then it's going to charge me an additional 30 cents for the API calls, right? So that's $23. If I do 1 terabyte per month of infrequent access storage, let's say I do the same 10,000, do 100,000 here. No, I'm not going to do any lifecycle or any data retrieval. We're going to leave all that alone. $13 a month. So about half, right? Give or take. Let's go down here to Deep Archive. If I do a terabyte of storage per month, let's say my average object size is, let's say 256 megs. I'm doing some file level, backups. And I'm going to access this very infrequently. Not really going to do any transitions. I'm going to do maybe 10 restore requests a month. Just kind of standard, right? That's it. It's going to cost me $1 for that terabyte of storage. So I hope that gives you an idea, not only the dimensions of pricing, which is going to be based on restores, amount of API calls, the size, the amount of storage that you use, but that should give you an idea. $23 at standard, infrequent access dropped to $12, $13, and then it drops to $1 for Deep Archive. So literally like 1/23, 1/24 of the cost. By the way, this is calculated at AWS. Keep that in your back pocket, or at least just know that it's there. If you ever need to do any estimates, this is a great website to use. Good. There's a bunch of best practices here that make a lot of sense. Bottom line, don't expose anything to the internet. Turn on encryption. Make sure that your security is set up properly with bucket policies or IAM policies. Prefer identity-based policies, but you might need to use bucket policies every once in a while. Make sure that you have lifecycle rules. Don't just leave storage to sit there. If it's not being used, it either needs to be deleted or archived. Look, if you archive it on accident and someone needs it back, just tell them to hold their horses. 12 hours later, you can get it back to them, right? No loss. Can't tell you how many times I've stood in front of data scientists in particular, and they're like, I need every piece of data that you have for the last 20 years. I'm like, oh, really? Okay. So what do I do is I stick it into an archive and they never ask for the data. Cool. I met their requirements and I saved the company money, right? Other things in terms of data protection, make sure that you use replication if one region is not enough for the company, because it may not be. And then turn on versioning for data that's sensitive, that you cannot stand if it gets deleted. Don't turn on versioning. Like I had one of my DevOps guys turn on versioning for the video file bucket that I was just telling you about. Every time we change the metadata on those 1 gigabyte video files, it would make a copy of the file. Make 10 changes to metadata, I got 10 gigs of files. That's a waste. Don't do that, right? But turn it on for like legal documents and stuff where people might go in there and change things, and you need all versions of that document. Or better yet, take it out of S3 and stick it inside of a Google Drive or something else that handles versioning and is actually built for corporations, for corporate documentation. Just my 2 cents. Okay. Use cases for S3. Anytime you have a data set that you can't predict how big it's going to get, anytime you have log files, video files, images, any web hosted objects that you want to share out with the internet, anything that has weird and random access patterns is also a great use case as well. Or those moments where someone says, well, I just need you to keep this for the next 10 years in the cheapest storage possible. S3 is your friend, particularly Glacier. Okay. Questions of any type about anything related to S3? I feel like a lot of information. I'm sorry. It is, like I said, it's a lot. Okay. So it's about 3:23. I know we already took an impromptu 5-minute break, but that was for an emergency. Why don't we go ahead and take a real break? Just to give ourselves 15 minutes to just like refresh, get the brains eased up. We're gonna run through these last 2 sections, and then we're gonna do some quick exam questions. And then we're gonna go through the databases, and we're gonna do a lab, and that'll probably be our day. Okay. So it's 3:23 right now. Why don't we say it's 3:25? Come back at 3:40. I'll put a timer up. Is that right? Yeah, 3:40. So come back in about 17 minutes. All right, we'll see you in just a bit. Okay, we're back. Anybody have any questions before we roll into the rest of the storage pieces? Okay. Okay, so let's talk about shared file systems. So we're going to move away from object storage at this point in time, right? So this is about network storage, right? Or file, sometimes what they refer to as file storage. So we really talked a little bit about EBS already, right? We had a whole thing about EBS with the GP2s and the GP3s and the IO1s and IO2s and the SCs and ST1s. We did have a little conversation about EBS already. So we actually have covered block storage, a version of it already. This is block storage that happens across a network. Now, don't get me wrong. EBS is actually running across a network, but it looks like it's direct attached storage to the operating system. This is actually network attached storage with network attached protocols. So it's not using iSCSI for this, right? So how do we run file servers, whether it's for Windows or for Linux in AWS? That's really the question that we're answering. And there's really there's 2 options. So it's a service called EFS, which basically is NFS for those of you Linux geeks out there. Or if it's FSX for Windows, which is where you run your SMB and your other file servers, like for Windows, right? Now, be forewarned, FSX has 4 flavors, only one of which is for Windows. The other 3 are for Linux. It's really strange. Sometimes Amazon's organization is a little confusing, but EFS has been around the longest, and it's the one that provides NFS version 4.2, if I remember correctly. And you just mount it inside your Linux file systems, and you can turn the dial on performance. It can scale up to, I want to say it's like petabytes of storage, but I don't remember the actual upper limit for it. And it is purpose-built. EFS is purpose-built to be shared across thousands of servers, hundreds, thousands of servers, no problem. EBS, oddly enough, even though it's a hard drive, it can actually be mounted across multiple systems, but you don't want to do that because it will corrupt. If you do not put a cluster file system on that EBS volume, it'll corrupt. It's not really designed for that. EFS is really designed for multiple servers to talk to it at the same time. FSX is designed for multiple Windows boxes to talk to it at the same time. If we look at how EFS functions, which is the Linux version of the service, you will note that there's the file system that you created, and then there's these mount targets in each availability zone. So EFS will span an entire region. And so every server in every availability zone can actually mount that single file system. And by the way, you can run a standard storage class for EFS. You can run a 1-zone storage class if you want. You can run infrequent access if you want to. There are different storage tiers in EFS. Most people don't know that. Now, a great use case for this would be like for web servers, right? You can also use it, for example, for backups. So for example, since it has 4 nines of availability and it's completely serverless, you don't need to manage any of this stuff, right? So you could actually have it running in one like region and then use backup to copy it over to another region. You can also, by the way, use what's called EFS sync to do the same thing where you can actually replicate it off to other regions. EFS will also work with ECS, EKS, and I believe it now supports Lambda. It'll support a serverless function running in Lambda, and it will auto scale based on throughput needs. So you don't actually have to set the dial and say, look, I only want to do 100 reads and writes per second. You can just say, look, auto scale, and it will actually auto scale up and down based on who's using it. So you can also use this, by the way, with SageMaker. That can be useful for machine learning algorithms and writing training outputs and stuff like that. Now, when you set it up, it basically sets up mount targets in all of the availability zones. And then when you go to resolve the DNS name of that EFS folder, it automatically directs you to the closest mount target in your availability zone. They're not single points of failure. Think again, this is a virtual device that has many, many devices underneath it. So you're not going to run into the typical bottlenecks and constraints because there are a bunch of servers actually acting as one. So that's EFS. So again, this is just like NFS. It just happens to be purpose-built for AWS. Okay. So that's EFS. What about FSX? Well, there's 4 flavors. There's FSX for Windows File Server. There's FSX for Lustre. There's FSX for OpenZFS for you old Sun Solaris geeks out there that then got ported into Linux. And then for you NetApp geeks who have used NetApp devices, there's actually Amazon FSX for ONTAP. So actually it just says it right there. I'm like pulling it out of memory and it's right there on the slide. So just know there's the full list. ONTAP and OpenZFS are not discussed in this course. They are very specialized edge cases. But file server, well, that's an easy thing. So FSX for a Windows file server was designed for enterprise applications, right? It's straightforward if you want to just lift and shift to put your Windows file server out on AWS. So it's going to support SMB, it's going to support NTFS, it's going to support Active Directory integration. What is that? What do they call that? DFS? Does it say it on the page somewhere? DFS, directory file system, directory file system. So, you know, it'll support DFS as well. It's mainly SMB3, which, you know, hasn't progressed a whole lot in the last 10 years. Still the same protocol. Now, FSX for Lustre is also going to provide a fully managed file system, but this is actually built, excuse me, for HPC and machine learning. This is for media processing workflows. So this is going to actually be, you can process massive data sets with hundreds of gigabytes per second of throughput, getting sub-millisecond latencies with Lustre. I've used Lustre in high performance environments and it's fast. Weird things, by the way, about Lustre is that it will automatically integrate in with S3, which most file systems don't do that because it's a performance disaster. Lustre does that by doing caching and all this other stuff. It's pretty cool. But if you ever need to like write your workloads to a file system and then write them out to S3, you can do it in one step with Lustre. Now, when you link Lustre with S3 data, it's loaded into Lustre for processing, and then the output is returned back to the S3 bucket. So, you know, it uses like a caching mechanism to execute that. So remember, EFS is for Linux, and that's the NFS protocol. FSX for Windows is like SMB3, so CIFS, you know, so Windows File Protocol. And then there's Lustre, which is actually built for Linux. but it's HPC protocol. So this is for millions of IOPS per second. Okay, those are the shared file system services, EFS and FSX. Let's talk last just very briefly about these data migration tools, because there's a couple. So first, just know that there are these snowball devices. There's like snow cone, snowball, compute optimized, snowball, storage optimized, and then there's the snowmobile. I was there in 2016 when they drove this 18-wheeler up on stage in Las Vegas, as if somehow we couldn't visualize what an 18-wheeler looked like. And then magically that 18-wheeler like followed us around wherever we went. It was like, it would show up in like the vendor hall and stuff. And we're like, how are they moving this truck around from the stage to the like dining hall? Like, how is this happening, right? Or to the vendor hall. It's kind of a Maximum Overdrive moment for those of you who may remember that movie as kids. It's very funny. So just know that Snowball is used to move terabytes or petabytes of data in a portable device from your data center to Amazon's data center. If you use the Snowball like storage device, it stores about 72 terabytes of data. And it takes a couple of days for it to restore back into your S3 environment. If you use the truck takes about 7 days, you know, assuming that you've got fast transfer speeds to transfer data into it. This is what it looks like. There's the snow cone, which is really a IoT device. It's not really like a transfer device. It only has 8 terabytes of storage, which is why I say that. Then there's the snowball. There's the snowball and there's a snowball edge. So there's a couple of different devices there. Kind of interesting that they have that. There's a snowmobile. The snowball and the snowball edge are the ones that take the 72 terabytes of storage. And the snowmobile can handle 100 petabytes per snowmobile. So it says exabyte scale data service. That's not true. It can only handle 100 petabytes. So I'm not sure why they call it exabyte scale. Maybe if you got 11 of them together. Now the process is that you request the devices, they get sent to you. If you do the snowmobile, by the way, you have to answer a bunch of questions and you have to get a deposit down and all this other stuff. It gets shipped to you, you copy your data to it, and then it gets shipped back to Amazon, and then that data gets copied into your S3 buckets. And so they present all the data to you. It's pretty straightforward. The snowball process does work through a network cable to hook into the environment. So it is all transferred over the network. So make sure you've got enough bandwidth for that if you decide to go that route. Moving past the portable hardware devices that can do data transfer, they also have this thing called data sync. So data sync is going to be able to facilitate the movement of data between your on-premise systems and to S3, EFS, or FSX server. So this is mainly for shared file systems. So you deploy this agent, it transfers all your shared file systems and puts them onto S3 or to EFS or to FSX. So you can also, by the way, use the database migration service as a data transfer agent, which will actually like hook into on-premise databases, and either one time or continuously, it'll replicate the data from on-premise automatically into AWS. And that can be an RDS instance, that can be Redshift, it can be other data sources, it can be DynamoDB. So just know that the DMS service also does that. So when we get to that in databases, you'll see that there as well. The other thing is that there is a virtual machine. It's a virtual appliance. It's called a storage gateway. So in addition to using the Snowball devices, in addition to the data sync tools that you can use, right? You can also just use a storage gateway virtual appliance. This goes into your data center with limited access to cloud. And what it will do is it will either act as a file server, it will act as an iSCSI server, like a disk server, or it will act as a virtual tape library. So it's got 3 modes that you can use it for. And when it's acting as a file gateway, it will copy stuff from your file system and put it onto S3 and then make that file system available back to your on-premise network. If it does volume-based, notice here that you can actually do volume-based, which is the middle one, which is iSCSI, or you can do tape, so an iSCSI virtual tape library. So it's got 3 modes that it can use to transfer files. So it can either act as a file server, it can act as an iSCSI volume server, or an iSCSI tape server. And it's going to copy the tapes back to Glacier. It's going to copy the files back to EFS or FSX, and it's going to copy the volumes back to EBS and S3. Most people don't know about the storage gateway, but it's been around for almost 10 years. So they will ask you questions about this on the exam, and they will figure prominently in the exam answers. Okay. So we just talked about Snowball, which is used for offline data transfer. We just talked about DataSync, which is an online data transfer agent, mainly for file systems. And then we just talked about the storage gateway, which is a storage appliance that runs in your data center. And it can act as a file server, an iSCSI volume server, or an iSCSI VTL server. Any questions? Okay, let's do a knowledge check. According to Amazon, which of the following is a petabyte scale data transfer solution? Notice I didn't say exabyte. I didn't say exabyte. I said, according to Amazon, which of the following is a petabyte scale solution? All right, let me back you up here because this is confusing, right? Amazon refers to the snowmobile as an exabyte scale device. Everything else, even though it only does terabytes, is considered to be a petabyte scale solution. Why does Amazon upgrade at one level? I have no idea. So I just want to kind of give you this one because this is just the way Amazon talks about it, is that they talk about the snowmobile, even though it can only do 100 petabytes, as an exabyte scale solution. But technically, for those of you who put A on there, you are technically correct. Snowmobile is the only one that can handle petabytes of data. But Amazon wants you to think of it as one level up. I don't know why. But just know that Alex and David, you were completely technically accurate. But if they ask you that on the exam, you need to go up a level. So the Snowball Edge is, even though it does 72 terabytes per, I guess if you put, 14 of them together, you'll get a petabyte scale solution. So Amazon wants you to think of that as the answer. Remember, there's the right answer, and then there's the AWS answer. You probably know what the right answer is, but for the purposes of the exam, if you go down that road, this is an AWS answer. Which Amazon S3 feature can force an action to occur after an event takes place within a bucket? What was it called when you could trigger an event, a response in S3? Did I just give that away? Notice I didn't say what you triggered. What is the feature of S3 that allows you to trigger something? Okay. So event notification is the name of the feature that will trigger a response. It can trigger Lambda, which is the thing that could be triggered, right? But that's not an S3 feature. Lambda is another service. So B is the right answer. Okay, you have 2 Linux applications in different availability zones that must share a common file system. Which of these solutions will allow you to mount one file system across all of the AZs in the region? There is only one. Let me see, Michael, but what about FSX? Well, hold on one second. Let's go take a look at FSX for a second. Doesn't that look like FSX would also span, right? So just so you know, FSX could actually be the answer here because it will also span. But what's the distinguishing thing here that makes EFS the answer? FSX for Windows is designed for Windows, right? EFS is designed for Linux. Good. Which of the following protocols are options in the storage gateway appliance? Oh. I'll give you a hint. There's 2 file share protocols and 1 disk protocol. Good. So remember, FTP is a whole separate object storage system, really kind of remote of its in and of itself. Fiber channel over Ethernet and fiber channel are low level storage networking protocols, right? So what you're left with is SMB and NFS, which are basically Windows and Linux file share protocols, and then iSCSI, which can do any storage object, tape or volume. So A, B, and D are the right answers. Good. Questions about anything related to storage? Did everybody learn something? Anybody not learn something? Even I learned something, especially with that last set of questions.
Go with the AWS answer.
In a few cases, Mike, a few cases.
Microsoft is the exact same way. It doesn't matter if you know 10 other ways to do it. It's always server manager.
Yeah. Kubernetes is the same way. You take the CKA exam, it'll do the same thing, right? They don't even have a company. They just have software. So good. Okay. Well, let's talk about database services, and then we'll do some review towards the end of the day of both storage and database as we kind of move through this. I want to get you to your labs as soon as I possibly can. Well, that reminds me. Okay. So let's talk about database services. And then, man, we will be well on track actually for day 3 and day 4. So this is perfect. This is actually a good question to understand. If you decide to run your database on Amazon's EC2, what of these things are you responsible for? To say this is that you're pretty much responsible for everything except for physical hardware maintenance. So, you don't get to dodge that, right? You get to dodge physical hardware maintenance because Amazon's going to take care of the physical hardware. But data backups, OS patching, scaling, if you can log into the operating system, you're responsible for patching that operating system. And that's true for EC2 because you can log into it, right? If you run RDS, by the way, which is the relational database system, you can't log into the operating system, so you're not responsible for patching it. But they're asking you for EC2, not for RDS. So, Amazon's always making the push that they want to eat your operational responsibility. They want to offload operational responsibility from you. So they want you to stop having to do all the, scaling and the database backups and the software. They don't want you to do that anymore. They actually want to take most of that purple away from you. So what's our call to action here, right? So the call to action is that, look, we discovered a lot more databases in operation than we had expected. By the way, every single place that I've ever done a digital transformation or a cloud migration or an audit for, every single one of those companies in the last 10 years, every single one of them's like, we have way more databases than I ever thought we would, right? So the need to narrow and standardize so that you don't have 15 flavors of relational database and 20 flavors of search engines and another 35 NoSQL engines that is super standardized. And everybody's kind of like, well, we all need our specialized flavor. No, not really, honestly. I know there's edge cases, but for the most part, you need an RDBMS, you need some kind of NoSQL engine, and you need something that's going to support search. You might need a graph database as a fourth option. Typically, once you've got those 4 technologies covered with a primary and a secondary, you're good. AWS has answers for all of that, including caching. So that's what we're here to talk about, is like, what are the options that AWS has for relational databases, NoSQL databases, search engines, data warehousing, and like graph databases? What do they have? What are the options? What are the possibilities? Also, can we do migrations? Is that possible? What does all that look like? So that's pretty much what we're going to answer, right? And if we look at our diagram, on the upper left-hand side, you can see DynamoDB, which, by the way, I can't remember the last Prime Day, but I want to say that they had a DynamoDB database that was handling like a million requests a second, like 31 million requests a second or something like that to the last Prime Day. Single table. It's a lot. And then we've got our traditional RDBMSs like MySQL, Oracle on this RDS standby primary thing over here. And then they've got caching next to it, where it is caching the most costly and frequently requested queries in the memcached instead of actually going to the database. So let's talk about how that works. So first, let's talk about data services. Okay, there's a lot of them. So note that in the top, right, just if we look at the core, these are the ones we're really going to just talk about briefly. We're going to talk about the relational database service. Aurora, by the way, is a subset of RDS. I don't know why they talk about it as if it's a separate product. It is not a separate product. It's a subset of RDS. It is awesome, just like Fargate's awesome. But it's a subset of another service, so I don't know why they call that out. Redshift is data warehousing. DynamoDB is a NoSQL flagship. And then Elasticache is either Redis or Memcached. Here's the cool thing about almost all of AWS's database offerings. They're all based on open source. Redshift is Postgres 8.1. RDS is, MariaDB, MySQL, Postgres, and then of course MSSQL and Oracle. DynamoDB is based off a white paper written in 2001. The open source analog is called React. You could actually run that in-house. I wouldn't recommend it. Elasticache is based off of Memcache and Redis. Redis is a very popular in-memory data store. The rest of these, DocumentDB is based on Mongo. Keyspaces is based on Cassandra. TimeStream is based on TimeDB. Neptune is based on Neo4j. If you are familiar with the open source database landscape, they basically have taken the most popular analogs in open source and they've made their own versions of them. Now, I don't know if I agree with that, but it's a business model. May not be super community friendly, but it's a business model. Moving on. So the relational databases such as Redshift and RDS, again, ignore Aurora. Aurora is a part of RDS, right? These are going to be SQL based, inflexible schema, not unchangeable, but less flexible. And it's going to be about, tables with rows and columns, right? Schema is going to be pretty fixed. If we do a not only SQL database, which is what NoSQL stands for, we're talking about document stores, search stores, because you didn't see Elasticsearch in there, but it is. They have their own version of Elasticsearch called OpenSearch. You could do key value stores, graph databases, and the schema is very dynamic. Does not rely on SQL to function. Because this is what we usually see in a relational database. Tables with data and relationships to other tables, and everything is relatively tightly coupled. And these relationships are enforced. NoSQL doesn't do this, at least not as strictly. But here's the problem. How much throughput do you need? What level of scale do you need? And then what level of data durability, data availability, data contention do you need? And do you have to use SQL? Do you need complex joins? Do you need super strong consistency and acidity? Or do you have a little flexibility? If you've got a little flexibility and speed is a little bit more priority than having strong consistency, you're probably going to use NoSQL. If you're like, speed is not that important to me, consistency is more important, like strict consistency, then you're probably going to be looking at a relational database. I will tell you, in most environments that I've been in, people use a mix of database technologies, and the relational database will be the system of record because it is highly consistent. And the NoSQL and the search engines and the cache database and the graph databases, those are all going to be your high performing engines for data that can be easily recreated or pulled from the relational database. Just throwing that out there, right? Because you need speed. In some cases, you need consistency, but pick the right tool for the right job. If you need search, you're not going to use a relational database. You're going to use Elasticsearch or some variation thereof. If you need something that emphasizes the relationships of the data more than the data itself, because you need a social graph, that's going to be Amazon's Neptune. That's not a relational database. So you might find yourself using multiple data store types in order to accommodate a single application for the different data search needs that you have. And that's how you choose the right database. Now, what about these specific tools? Because you keep talking about RDS, Michael. What's so cool about RTS? Here's the cool thing about RDS. This takes the databases that we've been using for the last 20 or 30 years. It packages them up into a server format, like EC2 server format. And you can enable encryption. You can spawn off all the read replicas that you want. You can actually create multi-AZ data replication. And it's all done with a click. Now, there are 5 flavors: MS SQL Server, Oracle, MariaDB, MySQL, and Postgres. You might be like, Michael, what about Aurora? Okay, so Aurora comes in a Postgres and a MySQL flavor. The only thing special about Aurora is that if you take the exact same data set in standard Postgres and RDS and you put it in Aurora, it'll be 3 times faster in Aurora than it will be in Postgres. Why? What Amazon did with Aurora is they took Postgres and MySQL and they modernized the storage subsystem for AWS, doing things that you can only do in cloud. And they made it so that the Aurora versions of Postgres and MySQL are 3 to 5 times faster than standard MySQL and Postgres, using the exact same data set, exact same schema, exact same queries, because they fudged with the storage system in Aurora and made it super fast. Now I say that. There's a second version of Aurora called serverless where you only pay for what you're actually transacting at the time you transact it and for storage, and that's it. So just know that Aurora also has a serverless version in addition to a servered version, but Aurora is just a flavor of MySQL and Postgres. That's all it is. It's a better flavor. I would highly recommend that you look at it if you're going to use MySQL or Postgres in AWS. But nonetheless, Aurora is just a different flavor of MySQL and Postgres. Just keep that in your brain. Now, when you go to use Aurora, this website that I shared with you, instances.vantage.sh, has an RDS tab. It's right here. If you click on RDS, this will show you the t-shirt sizes of the virtual machines that you can use underneath RDS. RDS is a PaaS. It's not a serverless system, but the servers are not managed by you. So it's a PaaS. So let's say that you're like, look, I want to use a DB. Really? You're not going to give me a T? That's interesting. I'm pretty sure that you have a T series. You must be broken. Because I know for a fact that you have a T series. So your last API scrape must not be working. Okay. So just to say this is that RDS has a couple of different instance sizes. There are actually T's out there. I don't know why it's not working. It probably did a bad scrape because it actually does scrape Amazon's API and probably is in a bad state. But regardless, these t-shirt sizes are the same sizes that you know and love over on the EC2 side, but some of these are purpose built for databases. You cannot log into these boxes in RDS. That's why it's a PaaS. That's why it's not infrastructure as a service, because you can't log into them. Notice they got two types. They got general purpose and then they got memory optimized. So they got the R series out here if you want a large memory box. If you go through the console and look at RDS, let's say you go out here and you kick out a box, right? Let me make sure I'm in the right region. Let's say we're going to create a database, right? And I'm not going to use like the wizard. Oh, maybe I will use the wizard actually. Anyway, notice that here's your flavors, right? Here's Aurora. If you do Aurora, by the way, it's going to say, hey, do you want to do MySQL or do you want to do Postgres? By the way, you can go serverless on Aurora, which we're not going to do. But let's say I really love Postgres. So I'm going to stick with Postgres for a second. I'm not going to use Aurora, although I probably wouldn't do that. Let's say I want to, use free tier, for example. By the way, when you do free tier, it's going to knock out a bunch of deployment options. So let's say I'm like, I actually want production. I can do multi-AZ instance, right? Just know that they just recently added a new feature called multi-AZ DB cluster, which instead of having one active and one passive, you can have one active and two passives. Each of those, by the way, database instances is in a different availability zone. So you can now span 3 availability zones with your RDS cluster. By the way, these are new changes. You couldn't read your passive box 2 months ago. Amazon changed it so you can actually read your passive box now if you want to. So anyway, you could come up here and set up a cluster just with a few clicks. We come up here, set our passwords, right? I could use either standard or memory optimized classes, right? So I could get a 64 CPU, half a gig of RAM with 19,000 megabits per second. Let's say I want to do provisioned IOPS because I just need the storage. It won't support auto scaling because it does that mainly for GP3. Here's the cursed default VPC, which we're not going to use. And then it's going to ask you questions like security groups. Do you want to do authentication? Is there any other additional things? Like, do you want to turn on encryption? Do you want to enable automated backups? Do you want to keep them for up to 35 days? What's your backup window? Like, when do you want backups to be taken so it doesn't interfere with your performance? All these questions here, look, here's an enhanced monitoring. We saw this in a question earlier. Here's performance insights, which I think someone mentioned the other day when we were doing a cram. It wasn't with y'all. And then deletion protection. And then I create the database and boom, does it for me automatically. It's going to create the database. I already set the username and password for the database. It's going to give me a DNS name. And then what happens is if the primary fails, the DNS name doesn't change. It promotes the secondary as primary and it changes the DNS towards the secondary. So it automatically gives you a DNS CNAME that automatically points to whatever system is active in the cluster at any given time. This is RDS. It's a sweet little database system. So if you're going to run an RDBMS, this is the way to do it. Now, notice here, we got a load balancer pointing to two web servers or application servers. They're talking to a single RDS instance. What I can do is I can go in and hit that multi-AZ checkbox or the multi-AZ cluster checkbox, and it will add a standby instance or two standby instances if I need to. In the event that the primary fails, it's going to promote the secondary to primary, and then it's going to create a new standby. But if it already has a box there, by the way, it's going to create a new secondary. So just know if it's two boxes and one goes down, it adds one. If it's three boxes and one goes down, it adds one. That's all it does. By the way, you're going to see anywhere from like a half a second to a 30-second blip as that CNAME rolls over. So it's not a seamless failover. Sometimes it takes a second for DNS traffic to reroute, right? So don't think that's a seamless event. It's not. Now, let's say you're not interested in failover. You just want to scale read performance, because that's one of the biggest things is that most like RDBMSs get overpowered on reads. Don't get me wrong, they can get overpowered on writes, but 80% of most RDBMSs is used for reads if it's being used in a healthy manner. So you can either cache that information, or you could actually just stick a read replica in front of it and have all your reads go to the read replica and all of your writes go to the primary. So in this particular case, you can see here in this drawing is that it's using a synchronous read replication to replicate between these two guys. Mainly, honestly, it's just going one way. And then what happens is that this application tier might know that it can talk to these guys for reads, but if it needs to write, it has to go over here. So that's done at an application level, but it'll say, oh, all my reads are going to go over here. But if I'm going to do some writes, they got to go this way. Right? That way you've got two systems designed for different purposes. And by the way, you could put 7 or 8 read replicas on that primary box. So, and by the way, those read replicas do not have to be in the same availability zone or region. You could put read replicas on the other side of the world if you wanted to. Now, we all know that that's going to create a latency problem. So I might chuckle maniacally, but you know that's going to cause problems. So just be aware of what you're using that read replica for, knowing that you might have anywhere from 1 to 5 seconds of latency before data gets replicated over there. Great for DR, by the way. So, by the way, if the primary goes down, you can actually take this read replica and you can promote it to a master, like a primary. You can promote it to a primary database. So you can actually use this for DR. It's pretty sweet. So you can promote it to be a standalone. Other things to know. You can encrypt all this data. And by the way, this supports transparent data encryption if it's Oracle or MS SQL. You can turn it on for Postgres. You can turn it on for MariaDB, you can turn it on for MySQL. There's no issue there. You can turn all that on, right? No problem. You can also turn on SSL, so you can force SSL between the client and the so both data at rest and data at transit. You can force SSL TLS to run, and you do have to provide certificates, but you can also get that from KMS if you want to. So KMS will encrypt your data at rest, and I believe you can get those certificates from KMS for the data in transit, but don't quote me on that one. That one I, for some reason, I'm not as certain about, but I'm pretty sure you can. So a reminder that Aurora is just a subset of MySQL and Postgres. That's all it is. It's just built for cloud, so it's faster. Aurora does operate a little differently in that it actually will build clusters with up to 6 replicas. So it's very different than your standard RDS. So, and you can actually have up to like 15, like 6 read-write replicas and 15 read replicas, if I remember correctly, in addition to the primary instance. So just know you can create up to 15 read replicas for an Aurora DB cluster. And of course, there's serverless, which I also mentioned to you, right? I would say test serverless because they're now on version 2, and it's actually pretty cool. But serverless is really ideal for databases that are infrequently used. They're unpredictable, or they have like cyclical workloads. If you know your instance is going to be used 24/7 because your database is going to be constantly hit because your application's constantly hit, don't use serverless. Go use something else. This doesn't work like ECS or EKS Fargate, right? This is a little different. So make sure you test serverless before you use it to make sure it's good for your use case, okay? It is cool, by the way. I mean, you have a database sitting there, and if no one's using it, you only pay for storage. You don't pay for compute. That's kind of nice. You just have to say that. Okay. All right. Let's get through the rest of this and we'll get to the lab. So any questions, by the way, on RDS before I go forward to anything else? What? All right, let's talk about DynamoDB. So key value data has a key attribute. You search for that key, like a username or a musical artist or a play, and then you can retrieve attributes. Now you can filter the attributes you retrieve on the server side, or you can filter them client side. Obviously, server side puts more load on the back end. Client side, there's more data transfer, right? So DynamoDB is considered to be the fully managed serverless no SQL database service. This is the one that people go after by default. This thing is designed for scale. It will auto scale in response to demand. It is super cost effective, and you can add indexes to this thing. You can put read-only caches in front of it to get to microsecond response times on reads. It supports end-to-end encryption. It integrates tightly with IAM. It has fine-grained access control. You can encrypt down to the field level. It's a great service. It's good. Here we got a load balancer talking to a bunch of EC2 instances in DynamoDBs on the back end. So it's great for leaderboards and scoring. It's also really great for temporary data like session data or shopping cart data. You can also use Elasticache for this, but DynamoDB is a really great use case for this as well. And the way this works is that there's tables, and you can have either a partition key or a partition key and a sort key. Sort key is optional. You can search for both, parts of the key and return whatever attributes are associated with that row, right? So you've got the table. Each row is an item. And when you find off the keys in that row, there are attributes like year, genre, height, age, awards won. You know, you could add whatever attributes you wanted to that field. You are capped at 400 kilobytes per row. So this is not to store massive data. 400 kilobytes per row. Most people don't run into that, by the way. If you're storing larger than 400 kilobytes, you probably have a web URL out to S3 or to some other location that has the file in it. 400K though, on your limits. You can actually set it so that it automatically responds to load, which is nice. You can also say, look, I don't mind you responding to load, but your maximum is here and your minimum is here. You're going to always pay for the minimum, but within that, it will scale, right? When you do on demand, by the way, the minimum is 0 and the max is no limit. But Michael, what if all of a sudden they started hitting me at 20,000 per second? Remember those service quotas that we were talking about before? I don't remember what the service quota is, but I want to say it's like 10,000 read write units per second. So don't worry about that. I'm not saying you shouldn't have monitoring on it, but people use on demand all the time and it works great. They don't break the bank. Now, I mentioned before that NoSQL systems are typically eventually consistent. They're not strongly consistent. You can force DynamoDB to not only be strongly consistent, you can actually force DynamoDB to be transactional, which is fun and silly. Just using RDBMS at that point in time, right? Other cool things about DynamoDB, in addition to being able to be flexible with the level of consistency that you force in both your reads and your writes, is that you can do global replication of data, global replication. And I don't mean global read-only replication, I mean global read-write replication. Is this strongly consistent? No. No, it's not. But it is eventually consistent. So if you're okay with a multi-region, multi-active, active database system that is eventually consistent to have your data replicated across the entire world, this is a great system to look at. So these are global tables. By the way, when you do this, you actually have to create the global table first, then create local tables, and then attach the local tables to the global table. It's so weird. You got to create this global construct first and then attach all your local tables to it. So if you ever end up doing it, just remember you got to create a global table first. So that is DynamoDB. Questions? Okay. Let's talk about the last two tools and then we'll hop into the lab. Easy peasy for these last three. So, hi, what you doing? Okay. So Redshift is the data warehouse, right? This is for online analytics, basically, right? This is for analytics processing for the most part. This is where Redshift comes in. Redshift was launched in like 2012. And I gotta tell you, people have a love-hate relationship with Redshift because it is really easy to run your data warehouse out there. It can be cost-effective. It can also be a cost nightmare if you don't really know the business value of the data you're storing out there. It stores things in a column or format, which makes analytics much easier, right? You can hook into it with JDBC, ODBC drivers of whatever sort you want. You can use proprietary connectors, like I think Python has a Redshift connector as an example. It has massive parallel processing capabilities, and this is purpose-built for OLAP. There are flavors of Redshift that will talk directly to S3, and this thing will scale. I think the biggest node I've ever seen is a 3.2 petabyte node for Redshift. That's interesting because that's also the same number that Chris told me. Funny. Anyway, 3.2 petabytes. So it's probably larger now, but that's the largest that I've ever seen. So this is where business intelligent data can be sourced. This is for any kind of analytics events. Machine learning can source their data from Redshift. Although, to be frank, most machine learning wants to source its data from S3. So just to be upfront about it. You know, and the thing is that when you're trying to compute the average, like, you know, the number of zip codes that are unique within a row, you're going to go down the column. You're not going to read each row. That's why columnar formats are better for analytics, because if you're looking for the average price of an item like shoes, you're going to find all the rows that have shoes in them, and then you're going to read that column. So columnar data is better for analytics processing versus transactional processing. So just know that that's why it's stored in a columnar format. Note that Redshift offers the ability to support what's called concurrency scaling, right? So this is where if you're using a cluster and you throw a job on the cluster and the cluster's like, I don't have capacity for that, it will actually spin up another cluster for your job, run the job while the other one's running its job, and then shut the cluster down as soon as it gets the output for it, and it will store it in the data nodes. So it supports concurrency scaling if it's activated, right? So this is cool because you can send it to a workload manager and it will spawn multiple clusters as needed to run your analytics jobs and then shut the clusters down when it's done. Pretty nice. You only pay for what you use, right? Redshift, by the way, comes in cluster node types. There's the Rack 3 and then there's the DC2s? Or is it DC3s now? I want to say they came out with DC3s, but let's go with DC2s because I know that's a thing, right? So these come with their own storage. They come with their own like compute cluster sizes. You will actually have to look at the Redshift documentation to size your cluster appropriately. They have little like some math and tools for doing that. That's all in the Redshift user guide, right? As far as like how you like take an RA3 node and how you take a DC2 node and what's the best to use. I would tell you that the RA3 nodes are probably favored quite a bit. And that's Redshift. Redshift is a data warehousing service. Any questions about Redshift? You should be getting a little tired right now. You're like, Michael, we're in the last hour. I know. It probably burns just a little bit. It'll be fine. We only have like about, 10 more minutes and then we got a lab and then we're done. Okay, so database caching. So last two topics, really simple. Here's the idea. You got a database. You've got some really expensive queries that run against it. You want to take those queries off of the database because you don't need, they're the same queries that are just being run again and again and again. And even though you've got an index on the system, it's still hitting the database in order to retrieve that indexed data, right? What if instead we could just put it on an offloaded cache, and every time someone wrote to the database, they updated the cache, right? So this is where you have a side cache kind of like setup. So this is not an inline cache, this is a side cache. And you can load this by like every time someone goes to hit the cache, if its data is not there, you can retrieve it from the database and then write it to the cache. That's called lazy loading. That's kind of efficient, but slow for the client. Faster for the client is every time you write to the database, update the cache. Now, the problem with this is that it's inefficient in terms of, it's less efficient when it comes to storage, but the client has a great experience because they're getting the latest data from the cache. Now, the flavors that you can use for this kind of caching is either memcached or Redis. These are open source projects. Bottom line things that you need to know. If you want multi-threaded performance and you want to horizontally scale, then you're probably going to look at memcached. If you want to run things in a cluster and you have any other requirements for pub sub, advanced sorting, multi-AZ failover, and the ability to back up and restore, which by the way is most of us, then you're going to use Redis. You're not going to use memcached. I got to tell you, I don't know anybody who uses Redis. I'm sorry, uses memcached. They almost all use Redis. So just keep that in mind, is that they are going to ask you questions like, man, I need a cache system that is multi-threaded. Well, unfortunately, they're talking about memcached. They're like, you know what? I need a caching system that has advanced ranking and sorting algorithms. You can do, you know, publisher subscribe models. You can do multi-AZ, then that's going to be Redis. Okay. Those are the real distinctions that you need to know between why you would choose one over the other. In real life, by the way, you're just going to deal with Redis. You're not going to deal with memcached. It's there for simplicity's sake because memcached is very simple to deal with compared to Redis, but Redis outperforms memcached in almost every other way. So now you might say, well, how do I get items out of the cache? Well, first of all, you can set time to lives and say, look, if it's 60 seconds old, it's too old. Get it out of there. Right? So you can actually set it to expire in the cache if you want to. You can also just bust the cache. You could actually just go out there and say, look, this is invalid if you want to. So you need to come up with like a cache management strategy if you do this, and it'll just be part of either the lazy loading strategy or the write through strategy or whatever strategy you choose. Now, talking about caching, since we just talked about Redis and memcache, I do have to mention just in passing that DynamoDB does actually have its own read cache accelerator. They call it DAX, DAX for short. This will provide sub microsecond. It'll provide microsecond level reads to your DynamoDB backend. So just know that it exists. If someone says, hey, is there a caching mechanism for DynamoDB that can get you to sub millisecond response times for reads? And the answer is yes. So let's say millisecond response time is causing lag. You throw DAX in there. Now you got microsecond response time. That's what caches are for. Caches are so you can actually get better performance for your users, right? The only problem with caches is managing staleness. Okay. Okay, so bottom takeaway. Memcache is if you need a multi-threaded system that will scale easily horizontally. Everything else, pub sub, advanced sorting, all that stuff is going to be Redis. I've said that 3 times. I just want to make sure I'm driving that home. All right, last but not least, does Amazon have database migration tools? And the answer is Amazon has application discovery tools, server migration tools, data center migration tools, and it has database migration tools. Let's talk about one of those. So Amazon has an agent that can run on your database in your on-premise data center, and it will one time or continuously replicate the data out of that database and stick it into RDS, DynamoDB, or basically, honestly, anywhere. It can support conversion from, let's say, Oracle to Postgres. You'll need to use something called the schema conversion tool with DMS to get that to work, but it will work. Now, can you convert all of these things on the left to all of these things on the right? No, no. So make sure you read the documentation, because some of these things cannot convert to everything, right? So just be prepared for some limitations, okay? But just know, DMS will actually transfer data from your source database to your destination database. The destination has to be on the cloud, so just Amazon limitation, just be aware. And then you can use the schema, the SCT, the schema conversion tool, to help you convert stuff over to different formats. Okay, let's do a quick knowledge check, and then we're going to roll into our lab. One, what's the benefit of using RDS in a multi-AZ configuration, A, B, C, or D? What do I get? Good. You all seem very confident about that. I'm so glad that you got that. Yeah. It provides failover between availability zones, not regions, AZ. So that's perfect. Good. All right. What type of Elasticache installations offers sorting and ranking capabilities for data sets? You don't really want me to say it a fourth time, do you? Did I not drive that home? It looks like you all got it. You're like, oh yeah, Michael, we got it. Okay. Not memcached. We're clear. Yeah, so Redis. Okay. Which of the following is true regarding DynamoDB global tables? If I want to set up a global table in DynamoDB, what needs to happen? Or what's true about them, actually, not what needs to happen. Remember, these are global tables, right? Global implies tables can be in different regions, right? And you don't have to worry about replication. That handles for you automatically. All the tables are active at any given time. And you don't even you don't select different instance sizes to adjust performance, right? They're all set to the same size. Like, not memcached. That's exactly right. It's not memcached. Good. Okay. I hope you didn't miss this one either. What type of storage does Amazon Redshift use? How does it store data? I think like Parquet and Avro, I think they all do this as well, right? Yeah, remember, this is a analytics database, so it's going to store things in a columnar format. Columnar format, focusing more on the columns and less on the rows. Good. All right, so make sure we're clear. D, right? Right, columnar. Which of the following is true regarding an Aurora database? Man, they're really trying to get you with those questions. Probably the most important thing for you to remember, even more than the fact that you can actually have, 6 to 15 replicas, even more than the fact that you got 6 copies of your data stored across 3 availability zones. The most important thing to note is that it is compatible with MySQL or Postgres. That's the thing to remember. Okay, good. So I see C across the board. You guys did great. Okay, let's roll into this one because this will be our last 40 minutes of the day. Is that we're going to roll right into lab 3. So you're going to create a database layer for your instances. Let me just check on this really quick. Oh, I'm going to need you to pre-warm one lab there, goofballs. Okay, go ahead and click Start Lab in your lab instances just to make sure that it starts appropriately. But basically what you're doing in this particular lab is you're going to install an RDS instance. You're going to create an application load balancer, define some targets and some rules, and then you're going to test connectivity to EC2 and test connectivity to RDS. By the way, I noticed that some of you are not doing the labs, which is totally fine. But just, I'm just assuming that you're not having problems. If you are, please let me know. Just want to make sure that everything's cool. So if you are one of those people who's having trouble with the labs, please let me know. Otherwise, I'm just assuming that you're either going to do them later or you already are familiar with the material and you're okay. But I just want to make sure I'm checking in with you because I noticed that some people haven't been doing the labs. So I just want to make sure everybody's okay. All right. So otherwise, go forth and conquer lab 3. And I will be here to support you in case you need any assistance. And yeah, go forward and let's do it. Oh, and by the way, there is an optional task to create a read replica in another region. So, and when you're done with the lab, I'm done with you. So I'll see you at 9:30 Eastern, 8:30 Central. But, you know, like I said, I'll be here in case you need support. But otherwise, I'll see you in the morning. So the minute you're done, you're done. Okay. All right.